Thank you. All right, let's see. Preparing to live stream. Now we're going to be on a 25-second delay.
Yeah, looking good, Luke.
You shouldn't have said anything. Let me turn the volume down and mute to YouTube so we don't have an infinite echo. All right. I think we can get started. First, I'd like to welcome everybody. Thanks for joining us this month. I also want to warn you guys, the topic that I want to discuss tonight, I haven't processed stuff, my Alexa. I haven't processed stuff, deep sky objects in a long time. So I'm a little bit rusty. But I plan on going through my workflow on PixInsight, and I'm hoping that Mark, Gary, Tom, everybody, Scott, everybody who's done this can, jump in, hopefully, and, add your 2 cents worth. But specifically what I wanted to talk about tonight was how to process after the image has been stacked. We can go through stacking another time if that's a question. So, because that does take a lot of time. And, I'm not feeling fantastic tonight. I'm hoping I can give you guys at least 2 hours. We'll see how it goes. But, if we need to have a follow-up, we will.
I have a question.
Sure.
As far as the stacking, I have 3 ways of doing it.
Okay.
Okay. I can use Deep Sky Stacker, which I've been using, but also run my mount and stuff with an ASI Air Pro.
Right.
And that will stack too. And I can do live stacks like for EAA or whatever. I can do almost live views. I'm just wondering which way is best, because now that I'm starting to use PixInsight, I'm not seeing much difference.
It varies, and you're right. Even PixInsight costs a lot of money. There's more flexibility with PixInsight. You can go in, but I tell you what, Deep Sky Stacker does a fantastic job. Sometimes, just for the simplicity, even though I have PixInsight, I might just use Deep Sky Stacker instead, or compare the 2 processes. I personally don't have the ASI Air. I know Mark does, and it's a pretty popular setup there. So whoever can comment on that, but I would assume they would be comparatively similar. I think the major difference might be, depending on computer, maybe the speed at which software might stack faster than another. I know that in PixInsight you can assign larger or different temporary directories that allow you to have more swap files that may help some processes along quicker than others. In Deep Sky Stacker, you can adjust that as well.
The ASI Air is really billed as the live stacking is just so you can get an idea what you have in the field, not for your final stacking. I don't use it for that. And you certainly don't have all the options for how you stack it and how you can extract narrowband, data from a dual narrowband filter set. So it's not as full featured as what I use. So I don't use it other than just to be able to see in the field kind of what I'm getting.
Yeah, I just didn't know how much it was really doing, because I've done a few images that were stacked with the Air Pro, and I've done the same images that were stacked with Deep Sky Stacker, and they looked very, very similar. I mean, a very, very little difference.
Yeah, that's not surprising. All right, we'll talk about stacking at another.
Yeah, I didn't mean to change the subject.
No worries.
I'm looking at, if we're at the very beginning with a stacked image and we're going through using PixInsight, I want to start with the best rather than maybe save a little time. You know what I mean? So that was really the point of my question. You want to start with the best data you have. Sometimes
it's trial and error to see which stack you like the best. I mean, I know that's a cop-out answer, but I wish I could give you something to tell, it works every single time the same way. But as all of you guys know, with astrophotography, that's if it was that simple, it wouldn't be as fun, figuring all this stuff out. But also it wouldn't be nearly as frustrating either. But anyway, and we can talk about stacking in a future workshop. If that's, I think we also discussed that previously. I don't know in how much detail, but yeah, that's definitely something we can explore, because there are, besides the programs you mentioned, there are a few others that are also useful, especially if you have a, landscape in the background. All right, so today, what I wanted to talk about was processing in PixInsight. But first, before we do any of that, if Tom had a beautiful image of the sun, and I wanted Tom to go over.
Of the sun or Saturn, you said?
I'm sorry, was it Saturn? Jesus.
Yeah.
I was
You asked me
just
about
looking at
Saturn
the
this
sun.
afternoon.
Sorry,
I'm thinking,
Tom. I
oh,
was just.
sun.
You're always doing the sun as well. I was just.
I do a lot of sun these days.
Yeah, I was just doing this, looking at the sun on YouTube as well. Sorry. Yeah, of Saturn, and you could really see the bands, the weather really clearly, and I think there was, I was curious. Did you use the ADC?
I did use an ADC, and I had to make a little gizmo because I shoot through a Newtonian, which automatically, because it's the ADC has to be set up so that when the two prisms are parallel, it's you have to be even. It's be set up on the horizon, and with the Newtonian, it changes all the time. And a German equatorial mount, you're in the same thing. I have a combination German equatorial mount with a Newtonian. So where the real horizon is in my optics, looking through the tube, is totally different than what's the horizon is from just the tube itself, not the optical piece. And so I made a little gizmo up. Let me share the screen. I'll just show you what I did. It's very simple.
Oh, yeah.
I always use very inexpensive materials like cereal boxes as my prototypes, which end up being my my final versions that I keep for years.
All right, I made you co-host, so you should be able to share.
Up there we go. Here we go. Okay, I'm gonna make this short and sweet. I have a couple of pictures of. I only have like 8 slides or 9 slides, just real quick. But this is the scope I used for it. And the reason I put it in here is because I refurbished it during the pandemic and it looks all new and shiny. So I wanted to show it off. It was built in 1968 originally. And it was just really beat up from years of traveling and taking places. So basically I redid the whole thing, took a mount all apart. It's an old Edmund Scientific mount, but I refurbished it. And while I was at it, I redid the mirror. The mirror on the left is what it looked like. You see the wicked turn down edge I had for 50 years. I used it that way. I just masked it. And then in the end, you can see like a raunchy, just raunchy screens, which I didn't even know raunchy screens existed when I was 15 years old and making the first mirror. But but anyway, this is the first thing though with the planetary photography is electric focuser. If you don't have one, it really makes life a lot more difficult. And I went really cheap on this because to the 6-inch, like that picture of Saturn, I'm still using the original Edmund Scientific rack and pinion 54-year-old focuser. I just put I bought a grab bag of cellophane for 50 cents a few years back. They had a couple of these timing type gears with little Allens and a couple of timing belts. And I bought the cheapest because I have several scopes and I wanted to be able to use this. I can't afford to re-put all the focusers and make them electronic and everything. So I went this Orion, bought the cheapest stepper motor focuser they had that fit their focusers. And I don't use their connections. I just put one of these little timing gears on. And I took one of the little knobs off the Edmund and just put a little, timing gear on it. And I have it Velcroed together because I use the same thing on all of my telescopes. I have on the 10-inch over here. I got it. Just Velcro. I take it off and just have it run on the slow motion. Same thing with the 8-inch. Even my solar scope over here, which I don't know if you cut off. I'm seeing the people here, but that also has it on the side. So I just use it for everything. So electronic focusing though is really important for like any kind of high power stuff because as you touch its scope, it's just jiggling all over the place. Anyway, the scope you saw was as I bring it to the star parties. This is how I actually use it. This is the scope. It's a 6-inch f9. It's on I have a permanent pier I finally put it in back in the fall. And I just mount all my scopes can fit on it, so that's convenient. But here's what I did. This is the my fake horizon, my artificial horizon. It's just some cereal boxes with a line level and a straight edge across there. And what you get is, because here you can see, if I zoom in, that bubble is level there. So that's even with the horizon right now. But the view through the eyepiece is this. Look at the angle it's at. So you can't just hold a level up to like a focuser on this German equatorial Newtonian. You got to find where the real horizon is. And one benefit of being in a really light polluted area is that I can, at nighttime, I can, without an eyepiece in there, I can see where it's dark and where it's not. So with that, I have my true horizon. So all I have to do is I just note what the angle is. And when I put the ADC in, when the two arms on the ADC are in the neutral position, they're next to each other, I just align that with this line here with horizon, because that's the horizon right there. That's parallel to the horizon. So if the arms are parallel to the horizon, they'd be out here. Then I know that at least that part of the equation is right, because that's the first step. So anyway, that's what I did. And in this setup, I just have, here's basically the data. This is kind of the soup and nuts of it here. I have a Barlow. It's a variable type Barlow. I can make it 2 or 3 power. It's an old Emmons 50-year-old Barlow and has slides in. I can change the magnification. Now, actually, I had it set for about 2x, but because the ADC is taking up space, the camera's further back, so it's like moving the lens forward, which increases the Barlow magnification. So actually, the Barlow with the ADC in there kind of works at 3x or 4x just from the distance if you calculate it out. So anyway, I basically had it with 3x. I put the ADC in next, and I'm using the ASI 462 M1 single shot camera. Use Sharp Cap. Sharp Cap has tools, by the way, just like fire capture for working with your ADC. It's a 2-step process. One, it allows you to, if you don't have a gizmo, you can play around to get your prisms parallel with the horizon, but it takes time and it's a pain in the butt. And then once you have it there, then you can move the arms and you can watch a series of two different numbers that you can watch on the screen in these long lines. And so as you move the arms get shorter and the number gets closer and closer to 0. It never really hits 0. And it fluctuates a lot with this Sharp Cap tool. But they'll go like 0.6, 1.1, 0.4, but you get it to as low as you can. And then your arms are pretty well set when you get it to the low. And just kind of like ranges. You can see it as you move the arms, the ranges change. So that's what I did. I didn't do a visual type of thing. I just did it with the Sharp Cap tool. The fire capture is something very similar. I farted around with gains like crazy because Saturn's not that bright and I wanted some fast frame rates. So I shot from about gain 300 on this camera with Sharp Cap. It goes from 0 to 600 the gain. I tried from around 200 to about 500. 500, man, things are getting pretty grainy. It's getting really tough to focus and everything else. It gets kind of goofy. So you focus with lower gain, you kind of work it up. And I wanted to see if the increased gain, which allows me to get more frames per second, was worth it if I stacked more frames in my best of stack, instead of stacking maybe 500 or 1,000, maybe you get maybe stack 5,000 frames out of 15 or something. I fooled around with this, and of the images I got, I took a range. It was kind of just an experiment. I wasn't trying to find the best seeing at any particular time, but this is just the range. And at around 360, I was shooting about 55 frames per second. And that seemed to give me a nice balance of frames per second without too much grain coming into the image from the jacking the gain up so much, keeping the spark down, you get with higher gain. So basically, the image I took it for 1 minute and 40 seconds. I wasn't sure how long I could let Saturn go. I looked back at my notes later and said you can let it go for about 3 minutes before you get smearing because of its rotation. So this was like 1 minute and 40 seconds. I got 5,500 frames, and I stacked 2,000 of them. I tried stacking with the same image. I stacked 500, 1,000, 1,500, and 2,000. I like 2,000 the best because it's the least grainy, because if you stack, because it's such, if you're going at these higher gains like 360 and higher, if you're doing like 500 frames, the image with very little touching in Registax gets grainy, gets kind of grainy really quickly. You know, you get these, it gets, you know, it's not smooth. So basically, this is kind of the sweet spot that I found, at least for that night in this configuration. So it's kind of a starting point. The image isn't the greatest in the world. It's no Christopher Go, Damian Peach type thing, but for me, it was my best image so far. And it's pretty clean as far as the color goes. I don't know how much the ADC helped me in sharpness. I took a couple pictures with no ADC at all. Maybe just a hair less sharp, but definitely the color, you get color fringes either inside the ring or outside the ring. So the ADC eliminated that. The sharpness aspect of it, I think if your seeing has to be pretty good to really get most out of that. This was kind of just an average night. I mean, things were moving around quite a bit. The video, Saturn was just all over the map. I mean, it's just really just pulsing. But anyway, so it's kind of the settings I used. There's the picture, which is the best I've gotten so far.
Did you use a cut filter?
That's right. And I use an IR block filter. So I forgot to mention that.
Yeah,
forgot all about that. Yeah, that makes a difference too. I found, because I took pictures with and without it, just experimenting all these different combinations and trying to write the name in on SharpCap so they're all in different files, so I know what the heck I'm doing at what time when I go back to process. But yeah, the IR filter helps too. Cleans it up a little bit. Anyway, so that's it. That's all I got.
Beautiful image, Tom.
Thanks.
Now I have something to shoot for.
Hey, Tom, I have a quick question with the ADC. How much did it change focus with that in the optical path? I assume it's not parfocal because of the prism.
It is, well, the thing is, I can't just take it out and then put the camera in, because basically with my Barlow, I'm adding a separation in the Barlow distance. So it actually,
Right.
you get more distance, so it's different magnification. So the whole thing it's way out of whack.
Yeah, I'm asking.
As you move the arms, I mean, the tricky thing is you're sitting here at this, you're at, 150-inch focal length type range, 200-inch focal length ranges are going to be at pretty high. You got to move the arms real slow, because even though you may actually start with the levers fairly far apart. As you move them a little bit, that image is going to shift on that little bit of screen you have. I always, when I shoot the region of interest, I try to make small and kind of fit the planet. But when you're doing the ADC stuff, use the biggest frame you got with your sensor, because it's going to shift quickly across the screen, across the field of view. Even a small tweak, it'll move, a third or halfway across the screen with a very small tweak. In the final setting, it would be 2 or 3 fields out of the range of the sensor. So you kind of do it in steps. You recenter, do a little more recenter. What I did not do, and I heard about this guys doing the stealth thing, they're saying, well, after you get the ADC set right, it's probably good to go back and recollimate the optics, because now you're not quite on the optical right middle. But with an F9 or F10, it's not that much of a difference. If you're shooting like F6 or faster, it probably makes a big difference, because you start going off, and without any kind of coma correction, you could find yourself in the weeds pretty quick, maybe.
Right.
But
okay, thanks.
Anyway,
Cool, nice shot.
but it's still a learning experience. That was only the second time I had it out. I had it out with my 8-inch kind of. Well, actually, I had it out 3 times. This is the 3rd time. I had it out with my 8-inch just to even see if I get it to work at all. And had just playing with the SharpCap tools, had marginal success. I was happy for what I got with the 8-inch, because before that, it wasn't even close to being a planetary image scope. But I took it out just using the SharpCap tools and no artificial horizon, that little thing I built. And I was struggling to get the horizon, because it just kept shifting, and I was over the map. So my image was better without the ADC in there. So I said, okay, I have to come up with a simple method I can do really quickly, just like a minute. And I got my horizon accurate, and I'm good, which it worked really simple. It's a real simple thing.
That's a good idea.
It's a very clever cheat there.
Easy peasy. And all it takes is a few boxes of Cheerios to eat, and you're good. At a small line level, some you attach to like a string, you know,
Yeah, yeah.
that laying around.
I'm just
Anyway.
getting started on trying to do some planetary, and the video capture that I use, you can crop. Basically, you can say I want a 480 pixel or a 1000.
Oh yeah, you can do that. Yeah, fire capture and sharp cap. You do that. Yeah. In
So
fact,
that would give you a bigger field for doing all the other stuff. And then once you're ready to actually image,
right. Yeah, that's what I was trying to say. I always use the widest sensor field when I'm doing the adjustments because it's moving so much. But once I get the adjustments where I like them, I'll crop it down and I'll even custom because it gives you a list of maybe 20 or 30 standard crops, but you can actually put custom in. You can put any number of pixels by any number of pixels. And so I crop it down pretty tight because it just helps with of course, when you get a certain size, the speed isn't really being throttled anymore by the pixels as much as the milliseconds of exposure, which is all about gain again, which more gain is more noise. So it's more frames you need. And you only have a certain amount of time to capture them, like 3 minutes on Saturn, maybe 55 seconds or so on Jupiter, maybe a minute. So it's a fooling around game. It's experimenting, but it's fun.
So Tom, a question about the game. Since I've never gotten even close to what you got with Saturn there, but finding the right game's always been a challenge, and at least for me. Can you go higher with the game if you have more, like if let's say if you're stacking 10,000 frames, would you be able to get away with a gain?
You need a bigger stack for the higher the gain. That's what you want to get. You want to stack more images. So if you're going to stack a couple thousand images, I was talking to several guys at Stellafane a couple of weeks ago, and all those guys said they never stack less than 2,000 frames in their final stack, which means you have to pick up 10, 12, 15,000 frames.
Right.
But you got to do this in 3 minutes or something. So you got to doing, 100 frames a second or more, you need that kind of range. So I adjust the gain. I always watch the frames per second of the camera. If it's down in the 20s, that's too slow. I know I have to crank it up. I mean, I think the lowest you want to go and get, the results I have just playing with it, you get better results when you start getting above about 40 frames per second. It starts to be noticeable at that point. So that 55 was better. I saw some images at 125 frames per second that night. That was 2 nights ago. And but the gain was higher to make up for that because I had shorter exposure to get through it. And I stacked them, but they were smooth. I had like 12,000 frames, but I was stacking 4,000 of them, to get rid of some of that grain. And in the end, I liked it better. Of all the images, this was my favorite in that range group, at about 55. So it's as low as I get the gain and still keep, above 50 frames per second, So this is a relatively small sampling here, a sampling size of just one night, but right. A bunch of different values. I tried a bunch of different things in one night. So I had a bunch of data, I had about 12 sets of different conditions. And that was the best. For that night, it was the best. Now it's better seeing. You might be able to go with 30 frames a second and lower the gain and only stack 500 and have a great picture. Yeah, you have to tweak it very little.
Good seeing is hard to find.
Yeah, it's tricky, and it's still low. Saturn's low. I can only get it for about 3. I have a 3-hour window, and it goes behind an oak tree, and then pops out for 20 minutes again, and it goes away. So, you have to move.
Chop
quick.
Down the oak.
Still my neighbor's property.
Even more reason to chop it down.
Chop it down at night.
Yeah, right on my.
Yeah, I was gonna give you a
message. It falls in their yard. Doesn't fall in mine. It's a big tree.
Well, dude, cut it down during a thunderstorm and just blame it on a thunderstorm. Right. Just a perfect cut on the
wind
bottom.
Kicks up, at night.
Yeah, just hook up a lightning rod to it. There you go.
Anyway, so that's. I know this year everybody's went and got these ADCs if they're hearing some of the reports. So I got one too, and I was anxious to try it. So I figured whatever I could learn, I could just share with you guys where I'm at with my first experiences, and you can add to that. correct me where you think I'm full of crap.
I bought mine last year. I still haven't used it yet. So I have to change the configuration to planetary, which I've been meaning to do.
But I would say the color is definitely better with the ADC. The lack of color, lack of fringe color just goes away.
Makes sense.
I was very happy with that. So
Yeah, well, our speaker that we had a few months ago was Agapios, who was very excited about the ADC.
yeah, I know he was crazy. I went out and bought one that same night. I went online and bought one that night. I said, "Wow, this really sounds good. I got to get one of these." They're not that expensive. I mean, they're not cheap, but they're not expensive. I mean,
They're not for what you get.
Yeah, it's a well put together piece of equipment.
Oh, before I forget, I wanted to show you guys. Costco today, 8 terabytes of space, $99. That's cheap.
8 terabytes.
8
8
terabytes,
terabytes.
$99. Costco. I'm not getting paid for this advertisement, but I know how much of a premium space is with planetary imaging. But
Yeah, they do. I mean, you go through, one stack, because you're shooting so many frames per second and everything. I mean, that one typical video, well, it ranged on basically how many I was stacking, but it would range from 2 to about 10 gigs, one video. And with the sun, they're all like 6 to 10 gigs. So if you do a bunch in one night, you're already chewing up your disk pretty quickly. You can go through it.
Yeah.
I have to keep monitoring it, because I'll easily go through 300 to 500 gigs in a session.
Well,
Especially those solar gifts, they really chew it up.
Was that an SSD, Lou?
no, it's a hard drive, but
Okay.
it's hard to say. Even still, $99. It's $12.50 a terabyte. I had 2 of them from before, and I was in Costco today. I just bought 2 more, so I have 4 of them now. One of them's already filled up to the max. So you don't want to keep these things filled up. So what I leave them like 70% full. So now I can spread the data around. So that way they'll. Oh, there's one.
This is 1 terabyte.
Okay. Is it
So-
USB? Yeah. Is that
And it's
USB?
solid state drive, so.
That's kind of tiny for 1 terabyte.
Yeah, and it's solid state. There's no electricity. It doesn't get, overheated.
How much did that cost?
I'll have to look it up. I forget. I bought it on
They're about the same price roughly. The one terabyte SSDs are around 120, around $120.
Oh, I was talking about, okay, this is for 8 terabytes. It was $99. So that,
No, I know, but as I'm saying, it's about the same price as your 8 terabyte.
oh, right.
There's certainly a premium.
Yeah.
If
Well,
you
there's
find
definitely-
a bargain, I on Amazon Prime Day, I was able to get one of the SanDisk 2 terabyte Extreme SSDs for $180,
Oh, okay.
just to put it in perspective.
Right. Yeah, I
So they're pricey. They're definitely at a premium.
The inside the PC, I have the Samsung 980 Pros. Those are they're pretty amazing. They're 7 gigabyte or 7 gigabyte per second transfer speed when you're going from drive to drive transferring files. I've never seen that. I mean, this PC was the first one I built in like 11 years, and the other one worked for 11 years. When I was younger, every 3 years I'd build a PC. But I was playing games then. But now, I had no reason to until I started doing processing. And the 980 Pro drive, that is very impressive. You need a Gen 4 motherboard to use it, but it definitely sped up processing, which I know I mentioned this the last time, but it improved how my processing skills with PixInsight, particularly because when you move the slider, you can actually go back and forth. The changes are almost instant, whereas before I have a change and then I move the slider, then I wait 2 minutes, and I have to remember, what did it look like before? Wait, and then you got to flip back, you know. So that's where I think the SSD, the solid state drives are really useful. But I mean, for data storage, I couldn't pass up the opportunity.
Yeah, that's great.
But
Hey, Lou, I have one quick thing. If you
Sure.
if you want to do like miscellaneous stuff before you do your processing, this might only take 2 minutes.
Go
But
right
I
ahead,
think
Gary. You can share the screen. It's all
I think
yours.
it affects I know it affects at least 3 of us. And it has to do with the ASI 2600 NC camera that I think I know I have, and Joe Lamb has one. I think Mark, you use that too.
I have one as well.
So
I'm considering
Scott,
buying it.
Yes,
I was
I use it. Yep.
I was shooting the other about a week ago, and I left the scope outside, you know, fully covered with the 365/7, you know, cover and all that kind of stuff. And I go out the next night and I take off the cover and I do some more imaging, and I noticed a little something in the image, and I thought, well, I'm not sure if it's a dust moot that's near the edge or something like that. I mean, the sensors, it's a fairly new camera. And so I bought it in at the end of December of 2021. So it came in the beginning of January. Anyway, so the next day I did flats, and I really noticed in the flats what had happened. So I have a couple slides, and I'll show you what's going on. But this is something that could affect any ASI 2600 NC that was made before the end of October of 2021. Now, even though I bought mine, I bought it on December 30th. I ordered it. It was still old stock. It was leftover stock from the end of October. So let me share the screen here.
Yeah, the same thing happened to me. And they took it back and gave me a new one.
Correct. Yeah. Yeah. I got mine replaced. The replacement came in yesterday.
Oh, I'm curious.
But I had a camera that was after the deadline. Hold on here. Okay. So if you notice here, where's my mouse? Okay. If you notice here, there's a little streak.
Yeah.
There's a little streak here, and there's 2 little streaks coming here.
That's water
So,
damage.
and I only saw this during the flats, and so obviously not good, because something's like dripping on the sensor. So I was able to take a picture of the sensor
Oh
by
boy.
catching the reflection of the outside light off of the protective glass. So if you see this streak, that corresponds to that thing on the lower left, and these little nubs here correspond to those kind of fingers hanging down. So what it is for the early production of these, and it's not only this camera, they said it also applies to other cameras, that the thermal pad that they use for drawing the heat away for cooling the sensor. So it's basically going between the tech and between the cold finger. So it's basically the cold finger to the sensor, really. That, if it gets hot, and mine was stored outside and it was 95 that day, so maybe that combination of things caused it to have a problem. The oil, the silicon oil, leaks from the thermal pad over the front of the sensor. So here's the if you just Google ASI 2600 MC oil leak, it will bring you to the ZWO page that talks about how to deal with it. You can, if it's an older camera, if it's out of warranty, they have a 2-year warranty. If it's out of warranty, they will repair it for free. If it's still in warranty, they will send you a brand new one for free, and they pay for shipping both ways. Early on, the people who first had this problem, that was not the case. They were fixing them, and then they were having the problem again because they were cleaning the sensor but not replacing the thermal pad. So it's something good to know, because and it might not happen. This wasn't all the cameras. It's only some of the cameras. Mine was fine, and then one day it wasn't. So just keep this in mind in case you guys see anything weird on your flats or on your images. Look at the sensor because there might be something going on.
Now,
Yeah.
Gary, the impression that I got from ZWO was that this was not because of some overheating issue. It was actually a manufacturing issue, and that they had come up with a fix so that
Well,
it
the
shouldn't happen in
actual-
future cameras. It's not like this is liable to happen with the newer models that have the fix in the manufacturing process.
Yeah, so the manufacturing process is that they replace the thermal pad with one that doesn't leak oil when it gets hot.
Well, there you go.
So that was the manufacturing. So it isn't a manufacturing process. It isn't a manufacturing problem. It was actually one of the materials that they were procuring to put in these cameras had an issue. And that issue showed itself when the camera got hot by causing leak oil, the silicon oil that was used to conduct the heat out of the sensor into the cold finger. It caused it to liquefy and then drip over the sensor. So the way they fixed it was they just stopped using those, right? So
Very
they went
common
to
problem, Gar. It's all over the internet,
a thermal
unfortunately.
sensor, a thermal transfer pad for the heatsink that would basically not leak oil.
Yeah.
Definitely useful piece
I
of
keep
information.
everything outside, but I strip everything down at the end of the night. Like I don't keep any cameras. I don't even keep any electronics. You know, the scope is out there and that's just about it. But I
Really?
Yeah.
reassemble everything.
But picture driving somewhere and it's in your car,
Right.
right? So
Right.
I mean, it's
Right. Yeah. I mean, you can't
don't-
eliminate it totally, but you know, when I take my cover off the telescope, you know, after a hot day, I mean, that telescope's pretty darn warm, you know, and
Yeah.
it takes a few hours to cool it down. I mean, I have a cooling fan and all that, but you know,
So,
for that reason, I'm very leery of leaving any of the electronic stuff attached, you know.
so
I always try to keep it in the house and for moisture as well, you know.
Sure. Yeah, well, keep this in mind. The nice thing is that when I looked into sending it back, ZWO has a link, you can send it to them. But some people said that they wound up, the early people, they had to send it to China. So their cameras were gone for 2-3 months at a time. And then they wound up getting the problem back, some of them. In fact, one guy that I saw this YouTube video, he had it happen 3 times. And then the ZWO had such a problem with it that they changed the policy that now the dealer can just swap the camera out. So I was able to send the dealer a picture. They confirmed that it was the problem based on that picture that I showed you, based on you know, the one that this one. And they said, yep, you definitely have the problem. We'll send you the new camera out. And then they sent me the UPS, you know, paid return label. So I was able to get the new camera at basically the same time they got my return,
Right.
rather than waiting for it and, you know, confirming that it really did have a problem. So I was only down a week.
it's
That's
it's nice
sad to
know.
hear, Gar. That's a shame.
Well, it's nice to know they have good customer service.
Definitely.
You know,
They definitely heard and their goal right now is to get all these cameras, these older ones, out of the field, because this problem could happen at any time with the older cameras.
So-
And it's only a certain percentage, but still.
curious here. This is specific only to cooled cameras, not to uncooled cameras, correct?
Correct.
Okay.
But it's not just this particular camera.
Right.
If
Just
you
the
look
cool.
at the wording, my bar is in the way here, but oil leak issue, this is a direct copy paste from their website on that model, the 2600 MC Pro and the other cameras.
Right.
And then the last thing, the free replacement or free repair, it not only applies to that, but also to other models as well.
Right.
That was just the most prevalent, you know, problematic camera. Okay, that's it.
So I'm surprised that my more than decade-old camera hasn't had any issues like this, but it's not cooled. And now I'm wondering if it's even, you know, I was gonna see if I can get that cooled because, you know, if the camera breaks, it doesn't owe me anything, you know. And if someone modifies it, doesn't do it right, you know, I won't pay them. But I do something I don't want to do on on an expensive camera, and then to wind up having a problem like that,
No, I think this is really unusual. I mean, there's a boatload of cooled cameras out there for decades. And, heat sink stuff has been around for God knows how long. I mean, silicon heat sinks, when I worked for GE Aerospace, we were using them in the 70s. So, I mean, a silicon heat sink thermal pads is not new technology. They just had a bad lot, or they just happened to have a bad vendor or something.
I see.
And it just was a bad circumstance. So this is the first time I've ever used a cooled camera. I've been a DSLR guy for a long time, for 2 decades. I am a firm believer. I mean, I am a dead firm believer in cooled cameras. The image quality. I mean, I'm out there on a super hot night. I can still cool down to minus 14 degrees C on a super hot night, and on a average night, I can get down to close to minus 20.
Wait,
you cannot beat that, and it's drawn, probably 1.5 amps of current. So you just can't beat it.
well, I'm glad you mentioned that, because the image that I was going to show you the work on, I was going to tell you to ignore the noise, because it's not cool. It was 33 degrees centigrade outside, and it's the Veil Nebula, so just if you can just watch the processes and ignore the noise. Let me start that, unless somebody has something else they want to share, another question.
I'm good.
No? Okay. And feel free to jump in anytime if something piques your interest. All right, let me see if I can share my screen here. Give me a sec here, share screen. I hope this doesn't knock me off. Now I have 2 monitors. How the hell does this work? Okay. Can you see PixInsight?
Yep.
Yep, no problem.
All right, fantastic. All right, so what I wanted to do, and I realized this is going to be impractical. What I first wanted to do was run through my processing workflow, and then I was going to make a 2-panel mosaic of the Western Veil. We'll be here all night. There's just too much number crunching, even though I have a pretty fast computer. So I could show you the end result, and what's wrong and what's right with it. But in the meantime, we can just start from the workflow, and we can go, stop me anytime with questions. All right, let me find the, all right, I think this is it. In fact, you know what? Hold on. I want to open this in a different window. So if you look down here on PixInsight, down the bottom, you have 1, 2, 3, 4. If you're not familiar already, all these are workspaces. You can add a workspace, subtract workspaces. The more workspaces you have, the slower everything runs. But standard, it runs with 4 workspaces. The second workspace is my main one that I use. I've also arranged the process icons in a loose order of how I use them, so I don't have to search through all here for what I need. Right, so what I did was arrange them, and then I set them up here. I named, there's 2 different setups I have that I use. So here they are right here. Generally, the process icons on the top are the ones that I use for linear processing. The ones on the bottom are for the stretched or nonlinear image. But it's not written in stone. Sometimes I use them for both. Okay, so let's get back to the image here. Okay, so here's the 3 images that pop out after stacking. I'd like to look at the rejection frames first. And this is, I think, particularly important when I'm doing a mosaic, because I want to make sure that I crop this appropriately so that we don't, you can create crazy tiny little gradients that'll drive you batty later on. All right, so this is the low, let's see here, rejection. And you can see there is, am I even in the right folder? I'm sorry, guys. I think I have the wrong image. Let me grab another, let me check to see where I was. Oh, that was the helix. I guess it could work on the helix. But to label the point, let me go back to my, the one that I was talking about. Monster material, where is it? This one. Nope. I'm very unorganized. Let's see. That's not it either. Here we go. Okay, this is the right one. All right, so there's two auto starch buttons up here. I'm assuming if you guys use PixInsight already, you know about these. The screen stretch button, and what this does is applies a temporary stretch to the image. It doesn't do anything to the data, just to what's being projected onto the screen. So this is the stretch that it normally comes to, but if you can use this boosted stretch, if you want to even see more junk. And this is one of the times that I like to use the boosted stretch, is when I'm looking at the rejection frames. So now you can see a little bit clearer where the edges are. All right, so there's that one there. And this one here, and you can see here, I don't know if this is coming through, but you see how there's like a little fold here? See down the bottom how this is dark here, and then it's gray, and a little bit lighter. I'm not sure if you can notice that or not, but where the mouse is. But that's one of the reasons why I do this. In the meantime, there's feedback coming from my amp. In the meantime, so what I do when I do the dynamic crop, and that's how I start off with, and here, yeah, don't laugh at the noise here. Look at the noise in this image. It's just ridiculous. So talk about cool cameras. I need to get one. So what I do is I open the dynamic crop, and I try to, let me close this one, get it out of the way. I try to line these on top of each other and see where the, which box is the smallest box. So when the images get stacked, because of dithering and field rotation, each individual stack shifts just a little bit, and it leaves this little area on the end that's not the full stack, and it can cause problems later on. So when you hover over the image with your mouse, it'll be half opacity or opacity, and you can try to figure out where the error is, where the image starts. And it looks like the black box here is going to contain everything, all the errors on the top part. Now on the bottom part, there's a very thin, you can't really see here, but you can see here. I don't know, can you see all that junk down the bottom? Anybody?
Yeah.
Yeah, at the very bottom.
Yeah,
Yeah,
you can see the different shades of gray and where,
Yeah.
where the alignments, where it's not, where it has to be cropped out.
all right, so that's why, so when I, put these on top of each other like this, then, we can figure out, and all I really have to worry about is this bottom of this gray box, because I can't tell on this one if there's anything, looks like everything's lined up along the bottom edge. One edge is always going to be lined up, right? Or should be lined up. So with the dynamic crop tool, then what I'll do is I'll just use it on this image. Oops. Come on, why is it not working? Something happened. Hold on. Okay, here we go. So we're going to make a template with this. And if you really want to be precise, you can zoom in even more to the edge. And I like to get as much of the image as possible when, especially when doing a mosaic, because of the overlap. You might, if you don't have enough stars, you're not going to be able to match it up the mosaic properly. Now, one thing, and I'm noticing, is this gray area here. I'm going to just leave that how it is, only because later on when we stack, that might affect how many stars, otherwise I'm going to lose all of this. You got to crop from that area there. So I'm just going to leave. I'm going to forget about that part. I'm going to tell you the exact opposite of what I told you not to do, but just for demonstration purposes, and I'm explaining to you why. And then we'll zoom in on the bottom, and we'll try to get this as close to the bottom as we can. And you got to go all the way along, because it might be fine on this side, but on the other side, it may not be. And we're pretty close. And you can see how much of this, that's really annoying to me that this happened. The other thing is that could be the result of just one single image. And if you can go back through your stack, and if you identify it, remove it. And that's only if things don't line up. So then you can take that process and save it on the desktop. You can check it here, and now you know that this is where we're going to crop. Did everything come out right? And it did not, because we missed this section here, it looks like. All right, so we'll go back and we'll crop this again. Anyway, well, it's close enough. So I'm going to delete this one. Okay, so that's where we're cropped. So now that we have the process there, icon there, we don't need these anymore. Put these out of the way. Now we can just apply this here, and we have the exact same crop. Sometime when you, depending on the technique that you're using on mosaics, you need the exact, or you want the exact same dimensions in the picture. It just makes things easier by saving this little the process icon here for the dynamic crop. You're ensuring yourself you're getting the same size on both images. But this only consists of one, so we're just going to work on this one. All right. So now we're done with the dynamic crop. I close that. You can still leave this on here if you need to use it later for whatever reason. The next thing I like to do is extract a luminance layer. So up here on the top, we do the luminance layer, and we'll apply the temporary stretch. And from here, this is how I start my processing technique. One series of adaptations or changes I will make on the loom layer, the black and white image, and the other one will be on the color. You can process these a lot easier, or a lot more completely if you do the luminance channel separately from the color channel. Any questions so far? No? All right. What I do on the luminous channel is deconvolution. Almost always I do deconvolution on the luminous channel. And rather than going through the deconvolution steps, I use this script right here, Easy Decon. And this is fantastic. If you guys has anyone ever used this before? Because this uses John Rista's method to, actually, sorry, not John. This uses, this does everything you need to do for deconvolution automatically for you. The next suite uses John Rista's method to get rid of the noise reduction, or to get rid of the noise. So all these are all wrapped into one. I wouldn't suggest starting off with these scripts first until you do each process manually. Just so you know the method behind the madness.
And look, this is part of the easy processing suite.
Yes.
Okay.
So, since there's a deconvolution is a very processor intensive process. And if we were to go through this, it'll probably just take an hour to go through everything. I'm going to save that demonstration for another time, or refer, unless you guys really want to do it, we'll refer to other YouTube videos that go through it in quite a bit more detail than I can right now, because I'm, doing everything by memory here. But one thing that I like about the Easy Processing Suite, that it does it all for you. So I start first by, all you got to do here is click this button. It will do the point spread function for you. Now, if you guys don't know what that is, when you do this manually, you'll have to go in and select yourself 25 or 30 of appropriate stars, so that it can, get a good statistical average of those of the air. It'll look at the area disk and look how quickly that happened. Now, to do this normally, you have to go manually pick the stars, and you just can't pick any stars. If they're too bright, it won't work. If they're too dim, they won't work. You have to follow certain parameters. So this just really makes everything simple. And then it also creates all the masks for you. So you create a background mask, boom. And a lot of times I just use this process, whether I'm using deconvolution or not, just for the masks. And I could tweak the masks from here. And this is, very handy for that. But the one thing I don't like about the deconvolution or these scripts is it looks like the whole thing is frozen, but you got to look down the bottom here where it says running. So I don't know how long this is going to take. Some of them tell you the time. I can't scroll back up to see if this did or not, but we might have to wait 2 minutes for this to finish. I don't know exactly how long. But at any rate, we'll make that mask, and then the other mask will make for us is a star mask. And what's interesting about the star mask is it will allow you to make a raw star mask, just generic star, or it will process one for you. So it'll make the star mask, and it'll apply predetermined parameters on there. Like it'll stretch it, it'll dilate the stars a little bit, and then it'll convolve it. And that will make sure that the mask is just big enough to fit everything. And you can fiddle with that until you get the right size stars. Now you can also zoom in from, you know, these little adjustments here, and change the image. I think you can even change it to a black and white image here. All right. Any questions so far about this?
And you're doing this on the point on the luminance layer only, the extracted luminance channel.
Yeah, deconvolute. Yeah, that's a deconvolution.
Right.
Yeah, since all the sharpness is going to come from that, it just makes more sense to use the luminance. And you can see here, I mean, I have it here. I have it right underneath here. But again, the other thing with my complaints about this is it's not readily apparent exactly what's happening to what image using these scripts. You just have to take it on faith, because this says running, it's still working, and you know, doesn't say done. I'm wondering if I'll slow it down if I create a new mask at the same time. I mean, we can start this, but let's see what happens.
Hey, Lou,
Mhm.
I have just a quick example of my current process flow that I'd be happy to do anytime. If you wanted to, while
Absolutely.
running, I could just quick show. I'm not going to be processing anything. I'm just showing the steps and what.
No, why don't you do that while we're waiting for this, Mark?
Okay. All right.
Is everybody cool with that?
Yeah.
Yeah.
Yeah, all right. That sounds like a good idea. I think I made all of us
Good.
co-hosts if you wanted to share. So whenever you're ready, go ahead.
So I'm going to share my desktop. Hopefully that'll work. Can you see my screen yet?
Perfectly.
Yeah.
So this is a PixInsight. Before I do that, I thought I'd just show a little bit of some of my madness and how I organize things. When I get a new set of images, what I do is I've got basically by year, and then by my OTA, I've got all the different objects that I'm shooting with the constellation that it's in square brackets, and then the name of the object. And then I capture, you know, which, like this means no filter, 300-second exposure, 0 degrees Celsius, 0 gain. And then I show where I shot it. And then I have sort of a standard set of folders. The images, the lights that I reject, I just grab it, put in this folder. My flats are in here. My lights are here. My master flat and the bad pixel map is here. And then I have a folder for the original stack. So this is the stack that I get out of Astropixel processor, and I give it the name, the object. In this case, I was trying to do a mosaic. This is panel 1, the year, the number of exposures, the exposure length, temperature, gain, and then the calibration frames I use, darks, biases, flats. So I will then open up this original stack in PixInsight, and this is what it looks like. This is the Shark Nebula. And this is, I shot this up near Cherry Springs State Park earlier this summer, well, back in July. And so this is the auto stretch stack that I have. So already I can see there's a lot here, and I'm happy with it. So these days, the first thing that I do is I bought this process. It's, you know, not for free, you have to pay for it, but it's called Star Exterminator. And of all the things that I've used to try to sort of reduce the stars, manage the stars, this works for me by far the best. You just drag it onto the image, and what it does, if you, it's a linear image, I ask it to generate the star image. And so when I've done that, I end up with the everything but the stars, the nebula, and then the stars. This is auto stretched. So you can see it does a really nice job of pulling out the stars without leaving a lot of star artifacts behind, which was my gripe with some of the other things I used to use. So then what I do after that is I just go ahead and I I do a noise reduction, and I still haven't stretched this yet, but the noise reduction. And what this doesn't look so hot. I've been playing with this. Same company makes a noise exterminator, very simple noise thing. And this is probably one of the areas that I need to learn more from Lou and others about noise reduction, because I haven't really done a lot with that yet. But anyways, we'll just ignore that for now. And so then I do a histogram stretch, and I get this, and then I do a curves, and in the curves I increase the contrast and also bump up the saturation typically. And then same thing, I do a histogram stretch on the stars. Now here you can see I made a choice here, and as an editor, I didn't want to have so many stars. I didn't want to have big bloated stars. And so by doing this histogram stretch, I can basically have very much control independently of the nebula about how many stars are in my final image. So you can play around with this forever. You could really, well, you leave the stars out, or you could put more stars in. It's completely up to you. And then I always, or generally, add a little saturation to bring out some more of the color in the stars. And then I just use pixel math to combine the two. And there you have it. Then the last thing I did is I just cropped around the area of primary interest here. And so that's my current sort of default workflow. This doesn't work for everything. Sometimes I need to use some background removal, some gradient removal and other things, but this is kind of my go-to Swiss Army knife right now. And this is just, Lou was talking about, screening the original images. This here, I went through Blink, and I can basically just scroll down quickly through all my images. And I just looked for images where there was a bump in the tripod, or there was some kind of glitch in the guiding, and just eliminated those. Or of course, if there's a big cloud bank that comes through. And so all the ones that are left over, then I processed. You can see I left some satellites in. There were some, clouds kind of coming through occasionally, but this is a pretty clean set. And so I used all of these to process my stack. And that's all I had. I just thought I'd give you a quick idea of the way I'm doing things.
That's all. Thanks, Mark, for that aside. One thing I'd like to add, and if somebody else can comment if they disagree, or have another way to do it. I like to crop before I do any processes on it, especially if you have to do background extraction or something, because then it's going to calculate those areas in when you're doing for ABE, for example. You want to get it all the way to the edge, only the data that you plan on, using in the final, so if there's, fringes on the image when you're starting, I think it's important to crop that first before you make any changes to the image.
Yeah, agreed. I've stopped drizzling, dithering lately. So I just didn't want to give away the imaging time for the dithering. So
you have to dither or die.
I haven't been dithering. So
you did this without dithering.
Yeah,
it's pretty impressive. I don't see any walking noise or.
Yeah, that's kind of why I stopped doing it. I'm getting pretty clean data, so I didn't really think it was helping me. It was just taking away from my imaging. In fact, that having the bumping where the scope is pointing, it just takes all that settling time before it starts imaging again. So.
Well, I don't, I can't compare with dithering or without. I'm wondering if you've done a direct comparison to see if there's a difference. But
I'm sure I'll probably come back to it. But I just right now I'm happy with
data looks good. All right, let me have my screen back here. Can you guys see my screen?
Yep.
Okay. All right. So now this process is done here. What let's see, I can boost the stars a little bit.
I'm not seeing your screen.
What's that, Gary?
I'm not seeing your screen.
No,
I'm seeing all the people.
I'm seeing you.
Oh,
There you go.
all right. So with this,
Okay. Now we're good.
all right, so with this process here, while Mark was showing us, I created a star mask. And I stretched it a little bit more than it came. And now what I'm gonna do to smooth out the edges is convolve it, even though this process is deconvolution, you wanna soften the edges, if you can notice the difference. Now, on this particular version of the script, it looks like they made some updates since the last time I used it. And I'm noticing that this, you can add an ellipse, which I haven't used this yet. It's the first time I saw this. Seems pretty handy, especially if you had a problem tracking, or if there is, obviously an object or two stars that are really, really close together that you want to include. So I'm wondering how that will work out. At any rate, so all the masks are created. I like to go about 85, somewhere between 50 to 100 iterations when we're doing deconvolution. I think 50 may not be enough. 85, I think somewhere, 70 to 85 is pretty good. If we go any higher than that, then we get some crazy artifacts. So yeah, 85 is a sweet spot. So, we'll run this, and here it'll tell us how far along we are. So, at least we're watching which way it's going. All right. So while that's doing that,
Lou, I'm looking at the screen, and I think that running down in the lower left, that's going to be there as long as you have the script open.
what do you mean?
Because I
In
think
the
that
process window.
you're in the process window there on the lower left,
What about it?
down lower.
Oh,
right?
the running thing. Oh, right.
Yeah, I
right,
think
okay.
that's just says the script is running. It doesn't mean that the script is doing anything.
Right.
The
Oh,
script-
right. Yeah. Sometimes it's hard to tell. With this particular one now, I'm seeing it move, but sometimes it looks like it's frozen, and I don't.
I think maybe it was done.
It could have been.
Waiting for you, I think.
It
But
could have
I
been.
don't know that. I don't use the script, but that
Right.
would be my guess.
Some of the that's what I was mentioning is not all of them. Maybe that one was fine, but I've ran into problems before where I wasn't sure if it was completed yet or not, because it wasn't it wasn't readily apparent.
I wonder, does this pause abort button, does that disappear when the screen stops scrolling like this?
I don't know.
Yeah,
Let's see
I'll have to pay
let's see
attention.
what happens. We have 3 more iterations here. So I tried to use that before. Oh, yeah, it grays out.
Yeah, it grays out. So that's how you know it's.
Now,
waiting
I
for you.
mean, you see how this is green now at the end? That's what tells me. That's what I'm used to looking at. When I see
Oh, but now
green,
you close the script, right? That's,
But- what's that?
the script is no longer open, right?
Yeah, it's right here. I mean, I don't need it
Oh, it's a
now,
process console. I'm just saying, while the script is open, like you had it open, the window,
right?
it was still running. Never mind. I'm getting us off on the sidetrack.
Okay, I mean, all right, I'm not sure I'm understanding what you're talking about, but what I was trying to convey was the only way I knew before was some scripts had, the text was green or red or purple if there was, or something like that. And that's how I was able to tell this was done. But you're right. I think before the process was done, it just said it was running. And I think we're looking for this button to be grayed out. On the
Lou,
bottom.
it says ready now. I think when the script
Right.
finishes, it goes from running to
All right,
ready.
there you go. Okay, you're absolutely right. Absolutely. Yeah, see, I'm not even paying attention here, but thank you. All right, so now we know that it's done. I mean, that's how I was able to tell before from the green. But now that I see the little ready button. At any rate, so now for this, we're done with the deconvolution. We'll take a close look. Now, it looks like you see some problems here with these stars. Now, just for the sake of brevity, I'm not going to do this over again. But what we could do is we can go back in there and rerun this process by dilating the stars even more. In the script. Let's see. You guys remember where that was?
Yeah.
You would push this button after you make the star mask, and then it'll make the stars bigger. Right? I think I only pushed it once. We might need to push it 2 times for this to get these the smaller ones here. Oops. Close the, see the black rings around there? All right, so I'm not going to worry about that for now, just for the sake of brevity.
You really don't notice those at full resolution, though.
Yeah, I could see them on my monitor.
I don't
clearly.
think they affect the image when you're looking at the whole image.
I mean, depends how much you want to nitpick. But at any rate, if you're happy with that, then we'll go to the next process, which is the noise reduction, and that's John Rista's script. Now,
Lou, can I ask one quick question about
Sure.
the decon?
yeah,
I've never been able to get it to run, and I'm not trying to debug necessarily. I just want to ask a question.
sure.
These scripts were written against using StarNet++
Yes.
as the mask generation, but that's been superseded by StarNet 2.
Oh, really? I have started.
So do you, and I've been having difficulty finding the plus plus. I have StarNet 2 in there, and it seems like that, from what I've read, it should work, but I've never been able to get it to work. And I'll debug it separately. But are you using StarNet++ or StarNet 2?
I'm using this right here, StarNet. That's what I'm using.
Okay. I need to dig
Now,
into
Gary,
this.
that should have came installed. It should have came installed with your P. I had to install it manually, but the newer version of the PixInsight should already have it included as one of the process modules.
Right, I know. I have, like, if I look at the process modules, I have StarMask, StarNet, and then I installed StarNet 2.
I don't even know about StarNet 2.
Yeah, it actually superseded the other ones, and it works quite well. I mean, I use it. I can use that for other processes if I'm doing, like what Mark was saying in terms of using the star extraction tool separately. The StarNet 2 does, essentially the same thing. Okay, never mind. I don't want to hold this up.
It's not this one. I haven't heard of StarNet 2, so that's an add-on I should probably get. Did it come already?
Basically is just a newer version of the StarNet.
Did that come? Did you have to do that separately, or did that come?
Yeah, it's free. I just when I went to check on StarNet, it said there's a newer version available, StarNet 2, and I did some digging into it, and people really seem to like it. It just works better.
Oh,
It's a more refined version of StarNet.
okay. Well,
And it's free, and it seems to work with the PixInsight tools. But
Okay.
I still haven't gotten the decon to work, and it's saying that it's basically an empty file name. So it might be something unrelated. So I'll dig into that separately. So sorry for the distraction.
no, that's good to know, because now I might look into. I never heard of called StarNet 2.
Yeah, StarNet 2. It just replaces StarNet.
All right, I'll look into that.
It's a free process tool for PixInsight. Just like the Easy Processing Suite's a free tool,
Okay.
or a set of tools in that case.
Okay. All right. Well,
The URL to download StarNet 2 in the chat.
oh, awesome.
Yeah, that's where I got it from.
Okay.
Yeah. It works quite well.
Okay. All right, I have that saved. All right, so the next thing I do here is the TVG denoise and the MMT. But rather than going through the manual steps, as described pretty clearly on John Rista's website, the script is based off of that. So we'll do the denoise this way. Same thing here. It makes all the masks for you. This process I like to run for like 1,500 iterations, and this takes a long time. I'm just going to accept the result it gives me, only because the data that I'm starting with now is already like kind of ridiculously noisy. So I'm not sure how much I'm going to improve it. I'm not going to wind up publishing this, but just to show the process, you know, it's making all the masks, going through the applying them when necessary. And again, I'm only running this on the luminance channel now, or the, you know, the black and white image. But the that's not to say that we can't use it effectively or somewhat effectively for the color data. We still can. When this thing is done, I'll show you what I like to do is use a few more layers on the MMT rather than the Loom. I think this thing only uses 7 layers, 6 or 7 layers when it's doing the Loom, and for color we'd want to use, or I'm sorry, only 4 layers for Loom. We want to use 7 layers for color. I don't know why that works, why the color responds better to more layers. If somebody can explain that, that would be appreciated. But just with my experience, what I found, more layers with the color, it makes it a little bit better, reducing the noise.
I'll try that out, Lou. I don't have an explanation, but I've only used the default on the color. I have never done the denoise, the easy denoise with just the luminance. And I just used the defaults with the color, with the RGB data, and it's worked quite well. But I'm anxious to try what you're suggesting here. It's, you know, since you're getting good results with it.
Yeah, the thing is, I picked the worst image to demonstrate for you guys here tonight. It's not really going to show off the power of this this tool because the TVG denoise and the MMT is really first time I did it, I was, you know, really, I was floored. I couldn't believe it, because I, you know, used the traditional methods that you know, ACDNR and the other, manually using the MMT, and I could never achieve such precision. Actually, you know what? I don't know if you guys noticed, but it actually does look quite a bit cleaner. The thing is, we can go back to, so here's before. Okay, you guys get a good look at this. And then we're going to go after the denoise. And there's after.
Yeah, zoom in on a section and do that, Lou.
Good thinking.
There you go.
There you go.
Oh yeah, yeah.
But the thing is, look how noisy my thing is. I got to get a cool camera.
You need a cool camera, man.
Yeah, I do. The next thing here I like to do, because of my, you know, my camera, my DSLR. Like I said, I'm working with a DSLR that was obsolete in 2009. I run this Canon banding reduction. I stumbled across this the last time. So I never start with the full amount, but you can see it removed. It looked like it shifted some, so I may need to play around with this till like we get the right number here. Let's try the full amount. Now that created a band right here in the middle, so I'm going to go maybe a little bit less. Let's try like 50%. 55%. There we go. Okay, it looks like I eliminated it. So it's just a matter of playing. I don't know, can you guys, I don't see any banding left. If you see any at all.
Yeah.
Hey Lou, if you want, I'll send you a picture of one of my Canon cameras and see if you can remove the banding from that one.
Yeah, is it really bad?
Oh, that's why I stopped using the camera. It's really bad on even low images. It's like almost every image had really bad banding in it.
Sometimes bias frames help with that as well.
Yeah, well, I mean, it was just one more reason to go to a cool camera.
I know.
And it makes a difference. I mean,
The
a
whole
single photo of a cool camera is so much better than anything I stacked with the DSLR.
rub it in. Now the thing is,
Oh,
I was looking at the camera you guys have, the 2600, but I'm noticing that the pixel pitch is a little bit too small for my focal length, and I'm using 1400 millimeters. What focal length are you guys using that camera with?
I've shot mine anything from like 300 millimeter up to around 1700.
And you didn't notice an issue with
Oversampling?
Yeah.
No. It's interesting. I had a long conversation with this guy Steve from Starzona when I was out there in February on vacation. And he said that with the modern cameras, if you look at the trend, all of the cameras are going to the smaller pixel pitch, right? So the dot pitch is getting much, the pixel size is getting much smaller. So it's basically sort of a sign of the times, because they're trying to get as high a resolution into a smaller piece of silicon as possible. And the fact that they're so good, their noise levels are so low, their read noise, all that stuff, and their electron well depth is so high that you don't tend to have as much of an issue with oversampling like you did in the past.
Right.
Yeah.
So it's becoming less of an issue because the technology has improved so much on the sensors themselves and the cameras themselves.
And one of the things, Lou, is the read noise, which was so much higher with the CCD cameras. The fact that it's lower now, that the well depth, I don't think needs to be quite as big as what was formerly needed,
Right.
But one thing you could consider, I mean, they're a little bulky, is a Peltier cooler. There are a number of videos on the internet on constructing them, and the results by cooling a DSLR can be quite dramatic. I mean, the amount of dark current is reduced like virtually to zero.
Yeah.
And these cameras online, these people that have cooled them, I mean, they can take like 10-minute exposures with very little noise, just a thought. They tend to be bulky, probably not something you want to do from a remote site, but if you were shooting from home,
right.
It's not a tremendous expense either to cool one, it requires a little bit of knowledge, but in those videos, they go through just about everything you need, maybe it's practical, maybe it's not, but
I started watching the link you sent me.
Sorry, Lou.
No, go ahead, Gary.
No, I was just going to reinforce what Joe's saying, because years ago I took one of my older DSLRs and I went to Walmart and I bought one of their little it's like a little beer cooler, I guess, that you can put a couple cans of beer in your car with and plug this thing into your cigarette lighter. And it was $35, and if you take it apart, you have a fan and you have the actual tech module for making the Peltier cooler. And then you basically can fabricate a small cold finger out of a piece of scrap aluminum, and then you bolt the tech module to the piece of aluminum, and then put that under the sensor. And Gary Honus, Joe, you remember him?
Yes.
From years ago, he used to do that as a service before he stopped doing that. But he also has videos for how to do this, and he has step-by-step instructions on his website for how to do it with the Canon cameras.
Yeah, down in Florida, like at Chiefland Astronomy Village, I don't know if they were still doing it, but that was kind of a big thing down there in the day. They were using DSLRs, and I mean, 95 degrees out at 2 o'clock in the morning, and 100% humidity, and I think they had to come up with the solution, just because the sensors were just getting so hot, they're almost unusable.
Yeah, I mean, one of the, I mean, that's certainly an approach, but an approach to take. And the reason not to oversell buying a cooled camera because they're not cheap, but the reason why I went with that approach over actually doing the final construction on this little Peltier module was because of other factors. So most of the newer ones use back illuminated sensors, so you don't have the metallization grid that's on a camera. On a standard camera, you don't tend to see that because in the daytime you got a lot of light and you don't really see that diffraction due to the metallization layers on the top of the sensor. So if you remember way back, companies like Apogee and stuff were selling back illuminated. They would lap the back of the sensor cell till it was really thin. They were $10,000-$12,000 cameras. Now you can get back illuminated sensors on a camera that sells for $900. That's actually cool.
Wow.
So, and then the other factor is amp flow. So even if you cool it, you still have amp flow on a DSLR, which you don't have on the newer cooled cameras. I mean, it's zero. So there's so much artifact. There's no banding. There's no amp flow. And they're back illuminated, so you get the most pristine capturing of sort of diffraction-free capture of those photons. And you also don't lose photons because it's bouncing off of the metallization layers on the front of the sensor.
All right, you guys have convinced me. I just have to come up with the money now to buy a cooled camera or add the Peltier. But Joe, I did get the link. I started watching that video. I didn't watch it all the way through. I had a couple of appointments, but I'll get through it. The thing with that guy's camera, though, that he was using, it had the LCD screen moved out of the way.
Yes, that's right. Yeah, but there are some others that encase the whole camera, where you don't have that issue. One of my Rebels are like that too. They have a removable screen.
Right.
But my 6D, for instance, does not, so it would take another approach. But there are several online if you're perusing them. I'll try to go through them again.
Well, I mean, Gary Honus was the guy who did my original mod. I think he offered the cooling service then.
He did.
But I didn't know the first thing about astrophotography when I got started.
Yeah.
It just that I needed someone said I should get my sensor modified. So I sent the camera out there. Had I known all this stuff when I first started out, I probably would have a few more bucks in my pocket and have better equipment. But I mean, hopefully that's what we're here to help you guys with, so that not making the same mistakes, newbie mistakes. Because it's easy to spend a lot of money on this hobby. Okay, anyway, let's get back to this the noise reduction here. Okay, so we got the banding done, the noise reduction on the luminance frame. Sometimes I like to apply a separate noise reduction on this using ACDNR. So I don't even know if I have it in my here it is. Okay, so I'll make sure that I have a mask on here now. The thing is, this is the mask isn't going to be stretched, so I'm not sure how effective it's actually going to be. But we don't need to worry about color. It's black and white here, and we'll hit the preview and get rid of these out of the way here. Now this is way too much noise. Look how it softened it. You can turn off the noise reduction and turn it on. Way too much. Yeah, so I don't like this at all. I mean, I guess we suppose we can go back and sharpen this, or we can try to remove the stars first. The problem is, now Mark's program does a wonderful job removing the stars with linear data. I don't know how well StarNet does with linear data. Has anybody tried it? Using it,
I've done it on both linear and nonlinear data.
and you had results? All right, so let's try it.
I've had very good results. I was doing it mostly on nonlinear data initially, and then I tried a technique similar to what Mark was talking about with the star extraction on just very mildly stretched data. There was
All
this. In fact, I posted a couple. Dan Stern was asking me about my workflow, and I posted the link to a YouTube video in the Astrophotography forum thing, and that's where I learned that from. This guy does kind of a modified version of what Mark was showing as his workflow by kind of stretching a little bit to get the stars where he wants them. Then
Right.
you run the star net on it and get rid of the stars, separate it, and process the nebulosity and whatever the sort of the deeper detail stuff or the fainter detail stuff.
Oh, I
and
see.
recombines them.
So you're saying he stretches the entire thing just barely so the stars are visible enough to remove.
Exactly.
And what about, and then does he stretch it again to get the nebulosity out without the stars then?
Correct. Yeah, and it's not so much to get the stars visible to remove. It's more to get, because it removes them quite well even with linear data. But it's to get the stars to kind of a point where they're not going to be overbearing or over dominant in the final image later on, from like bloating or from just getting too bright.
Look what happened.
Oh wow.
We did this with linear data. So
Yeah,
that's
Gary,
not-
that's kind of like what I'm doing, except I just have to do the steps afterwards to adjust the stars. So it's like you could stretch the stars before you remove them or after you remove them.
Exactly. Yeah.
Yeah,
Yeah.
well,
I've done the same thing, Mark. I've tried it both ways, and there's little pluses or minuses. Both ways work though.
it didn't work for this one though. It was all the blockiness around the stars.
Yeah, that didn't look good.
No. All right, so I'll forego that for now, but
Yeah.
all right, so then when from here I can just stretch this image a couple of different ways we can do it. Let's try what you guys were just talking about. We'll just stretch it manually. Where's the here we go. Where's my mouse? Screen transfer function, and then histogram transformation tool. Give me a second here. I'm working with two monitors. Okay. And you know what I'll do just to make space on this desktop here. I'm actually going to move this is the original one. I'm going to move this to another workspace. So where's the how come I don't see the icon to move? Here we go. Let's go to workspace 1. And will this move to workspace 1? And I'm going to leave the clone in workspace 1. Okay. So now, since I don't have the icons in this workspace, we'll have to do it manually. Where is the?
So do you save your process icons right on the as like if you right click on the desktop you can save your process icons, because I use when I start PixInsight now I just have my kind of standard process icons that I've saved separately on the desktop.
Yeah.
Like not as part of a project file, just as the icons file.
Yeah, I have them saved on the second workspace. I don't have them saved on this workspace.
But you could open them, right? Still, you could right click on the desktop and say load icons.
That's right. No.
Try right clicking on the desktop. And then load, and then there's process icons, load.
I gotta find them.
Oh, no, never mind. Never mind. Yeah, I have mine in a separate folder. You might want to try that because I've been able to just open them as a separate file.
I mean, I have it on. I have it on the other side, but well,
Okay, never mind. Go ahead.
yeah. All right. Anyway, and the SCNR. Or, I'm sorry. That what's the other one? Screen transfer function. Okay. So let's take a look here. How much do we want to stretch this? Your guy, what was your suggestion? Do you like 20? Do you go 25% of what you normally would do? What's the name of this one? Is this the one? You know what? Why am I making things difficult? Okay. Let's bring it in some then first. How far would you go before you would use it for these stars? I mean,
Yeah, I'd probably pull them up a little more. I don't like. I like.
'cause you know what? There's no noise here. There's very little noise this way.
Yeah. I like seeing the stars. I don't like the, I mean, I think it's kind of cool. The starless images are ones where they're really suppressed, but I don't tend to favor those. I tend to like seeing the stars. I just don't want them dominating the,
Well,
becoming too powerful. Cause there's some images like if you, like I did one of that one I did of M8 and M20 where they were too in your face.
right. I'm thinking here as just making this just for a mask so that we can use these to protect the stars we want. And, because if we stretch it fully, then we get all the noise.
Right, yeah.
So if we, leave it this way, maybe we apply it like this, create the star mask using that star net. I don't know. I mean, that's an idea. Look, I'm just doing this on the fly now. I just, I'm so unprepared, but I'm just trying to work in what you guys have been telling me here. Does that make sense to try that method? Yeah. All right, so let's see if we can do it this way. Maybe a little less to get rid of more noise. So that we're not worried about the nebulosity yet, right? So on this, okay. So let's see where we are. How do we move this down to the other side? How do I'm not familiar with my way around this here.
What's that, Lou?
The histogram here, I want to shift it. It doesn't matter. I could see the whole thing.
Oh yeah. I know what you mean. Yeah. I think you have to you can use the wheel, the mouse wheel. I think can stretch it back.
Nope.
Back and
Hold
forth.
on. There we go. Yeah, there you go.
Yeah.
Okay. This is a really sloppy, I didn't know about the mouse wheel. Thanks for this tip.
You're
Gary.
welcome.
All right. I'm glad we're having these tutorials. This is a lot of fun. I told you I was really rusty with this stuff. Here we go. Well, that's too much. Well, what if we just use this right here for the template and then go from there? Okay, so we'll go to the StarNet again. And a lot of this madness is just trial and error. You know, aside from watching YouTube videos, you're just spending a lot of time playing with the PixInsight. And that's one reason why having a fast PC has really helped my processing, because everything is, you know, you can see right away the changes you're making. It's much harder to do when you have to wait a half an hour for a star mask to be made. And then you forget, oh, wait, what was this for? Well, let's see how this works out. Because now we have this, we can use this to protect the linear image on the other screen. Okay. Close this. It's already labeled star mask. Yay. All right. So where's my, here we go, workspace 2. And that's what's left over. So here we go. So to apply the mask, I'm assuming you guys know this trick. You just pull the star mask tab over to the side tab here, and it turns this tab brown.
Yeah.
It's brown, you know that it's masked.
The one thing I find confusing, this is like relative to something like Photoshop when you're creating a mask. So if you're doing a selection, yeah, leave that view up. So if you show the mask, it kind of looks like everything has the mask on it, but I guess it really doesn't because the white's showing.
Right. Well,
And because it's red, the red protects, right? So
right. When you invert it, yeah, it's.
so maybe that's a better view. That would be easier for me to see if I inverted it.
But sometimes, you know, confuses me. It depends on how much things are stretched, and you know, you're right. I run across the same issue. I'm not sure what I'm looking at, what, but you're right. And you can change the color too of the if you right click on the image here. I think you can change the whatever color this is.
Oh, right. I did see that. Yeah, yeah.
Rendering
Yeah,
mode.
you can change the mask color.
Yeah, like yellow or I don't know if I like yellow so much.
Yeah,
but
the red's fine.
Yeah.
I'll try inverting it. I don't think I tried that because that to me looks more
Well,
like, you know, what I'm expecting.
that also inverts the mask, you know, so.
Oh, right. That's true. You need to invert it back. Yeah, yeah,
Right.
before you apply it.
Right. So if we hit Control K to hide it, and now what we can do here is cheat a little bit. Wait, is this is the linear image still? All right, forget that. Forget my little cheat. So now I'm wondering if we stretch it this way. No, that won't work. We'd have to invert it, right? So if we have it inverted, okay, maybe not. I'm getting confused. Okay, so Control K, let's see. So the stars are not protected. So the stars will get stretched. So if we invert it, Now, when we stretch it, the stars won't stretch as much.
Right, you're gonna protect the stars.
Right. All right. So let's try that. So here we go. Go back here. Close this. Oh, we gotta get rid of it. And this is too big for me. And we'll go to the screen transfer function. Now let's see what we get. Let's rename this. Oops. I'm not sure how much of a difference that made. Where's my little carrot? Here we are. I don't know, guys. I don't think that my little addition here helped. It looks like it added noise, doesn't it?
And it's hard to tell from the remote, but it does look noisier.
All right. So sorry to waste your time on that idea, but
So you, at this point, you would just back that out?
yeah, I just cancel this. And then what we would do is I would just remove the mask. I'll still keep, I'm not gonna delete the mask, I'll just remove it. And I mean, we can do, why don't we just try doing a mask stretch? Here. Intensity, transformation. Just lost it. Well, look at all the, this noise is terrible. Maybe that was better. I wish I had better data to share with you, but anyway, we can do it this way, and I'll duplicate this, and then we can compare. And then we can go back here, we'll go backwards, and then we'll do it the old-fashioned way, where we'll just do the screen transfer function and apply this to here. And Westernville, here we go. Are those two carrots right in here next to each other?
I think so.
Oh, wow.
Yeah, because it's really narrow.
Yeah,
The data band's really narrow.
very narrow, you're right. Now I'm starting to lose some of the nebulosity here. Bring up the darker areas. Again, this is an argument for a cooled camera. A lot of this, you know, if you polish a turd, it's still a turd.
Yeah, that's true.
That's what I'm trying to.
Yeah, there's a lot to be said for DSLR cameras. They work quite well, but
Right. All right. Well, you know what? This stretch looks a little bit cleaner. It's not as bright though. Let's see if we can bring it up brighter. It's too bright. Oh, come on, man. Let's decide on that. Okay. All right, let's see here. This one and this one. Well, this one definitely is better. This one's way noisy. So I'm glad we did it both ways. The problem is now we don't have very good definition on the you know, the nebulosity part. I wonder how much the color will bring back with that.
And that's also a time where, like, the technique Mark and I were talking about, where using a star extractor, you could grab the stars out, pull the stars out of the image at this stage, and then
Okay.
work on that nebulosity.
Good thinking. Very good thinking. Why don't we do that? You know what? I'm going to duplicate this, send it to the first workspace in case we screw it up. We have a copy of it.
That image of the veil that I posted just to the general groups IO thing, you know, from my front yard where it was fairly hazy that night,
Right.
to see what could be extracted, was done that way. I kind of got it to this point. Then I pulled the stars out and then just started to work on the nebulosity in RGB mode.
Well, let's see how this works, because it's definitely cleaner this way.
There was another technique I saw which was quite kind of cool. It's on it was from this High Point Scientific workflow thing that I sent a link for, and it was using the LRGB combination with just the luminance layer added back in to increase saturation.
Yes,
And
that's
it worked.
exactly,
It worked really well. It was a really like not an overbearing way to increase saturation. A very natural way of increasing saturation.
that's one. Sometimes I'll use that. Sometimes I'll use pixel math to recombine them together. When you
Okay,
get,
right,
is that
right.
what you're talking about?
Yeah, exactly.
All right, so here we go. Here's the nebulosity. And now the noise is shining through, but we'll still work with this. So let's see.
Yeah, but now you can do things with curves to sort of get that
Exactly.
noise to disappear.
Yeah,
Yeah.
let's see. You would put curves at this point. I was considering on doing another histogram transformation. But you
Yeah.
think curves would
Yeah,
be better?
you could try stretching it first a little more. You can get more stretch out of that.
I think maybe a little more right.
Then you could use curves to kind of lock the black point down and then pull up the middle. Uh-oh.
So I generally do my histogram peak at the first grid line there from the left.
You mean
Sometimes I
here?
do less, but that's as far as I usually push it.
Yeah, this line right here.
Well, to the right of it, the grid
This
line.
That line
Yeah,
there.
yeah, that's kind of where I put my peak there. Sometimes I get things I don't like and I'll back off because some stuff just gets too bright, but
Yeah, right now I'm looking at this.
Yeah, you got a lot of noise.
Yeah, and I would
You
love
might
to.
need to do curves first.
Yeah,
try the curves because with the curves, you can really sort of make
Yeah.
that stuff that's pretty dim, the noise.
yeah. Look at
just
it.
completely
There is
gone.
look. There is. You're right. There is a lot of information right here. Look at
Yeah.
all that. You're right. All right. So let's try that. Curves is right here.
I would start by stretching the RGBK.
This is all luminance data.
Yeah, I guess you're right. If it's a monochrome, it doesn't matter.
Lou, put your click on the image itself in that sort of the gray area, the noise to the like upper left of the nebulosity. Just regular click to see where the values are on the curves layer.
Oh, right. You mean here?
No. Go into the black. Go to the left more. Yeah, like maybe a little closer to the nebulosity, and then click in there. Just see where it is on the in the histogram.
Well, we're looking at it, right?
No, if you click, it'll show up in the histogram where you click.
Right.
What do you mean? I'm clicking on. I'm not sure.
Now you see the line that appeared in your histogram.
Yeah,
So
That's
that
where
point,
the data is.
that's where the what?
That's where the data is.
Oh, right. Yeah.
So you can kind of lock down those points. And on curve. You're still on what, histogram transformation?
Yeah, histogram transformation, right.
Yeah, go to curves
So we go back to curves.
and then click in that same area.
Oh, it tells you on curve. I didn't realize this trick. Shit, I'm doing this shit manually. Thank you,
And
guys.
so then you can know exactly where to lock down your curve.
Oh, wow. I was just going like this. Okay.
Yeah, I didn't
So
know
go-
that trick either, but yeah, I just been doing it visually. I'll grab on the lower left and pull it down until I get the black point where I want it.
Yeah, but then you're kind of guessing. With this trick, you can kind of lock in the value, and then you can put a point right next to it. Put 2 points next to one another. Then you don't affect anything in the bright zone. You can really just pull the dark down without affecting anything. So, and then put another point next. So then put another point right next to that.
Oops.
And now you can pull that bottom point down. Well,
All the way?
you need sort of, it's hard to explain. It would be easier.
Do you want to
I don't know. I don't have pictures. It might take.
What am I doing wrong here? Am I looking, are we, first of all, am I looking at the right preview?
I can't show it right now. I figured out what was wrong with my Decon. There were the reference settings for StarNet were not set by default, so it's still in the background running.
These are in the right spot because we can look against the.
Yes.
All right, so why am I not making any changes? Is what I'd like to know.
So you need the preview mode. You're not in preview. So
Hey,
go
move!
the
Hey, move, my
little
stuff.
circle.
Yeah, there you go.
Trying to
Now
bite
you
me.
got it.
All right, so we're looking right around here. And then you want me to, yeah, well, that's what we just were doing.
Yeah, but you're not on preview,
This is the preview right here,
is it?
the real-time preview.
I don't know. I never work on lightness. I work on chrominance. I don't know if that'll make a difference for monochrome.
Let's try it. Well, first of all, let's preview again.
Yeah.
All right, lock this down here and then here. Now it's
There you
working.
go.
Yeah, that was it, Mark.
What were you doing? You had it
You
selected
had
for
lightness.
Yeah, I
and
had it
chrominance.
on luminance, lightness mode. Yeah,
oh, I see. Yeah.
and I figured because it wasn't a black and white image, that's what I guess I figured wrong. All right,
So
so
you need it to still be RGB?
yeah.
Okay.
Now I'm noticing I don't know if you guys can see it here, but it's definitely pixelated on this big star area. It's faint, but it's what we're gonna get because of the quality of the data. Now I like this contrast a lot better than what we had before. I don't know. Let's try this. I think.
Yeah.
Close the preview. Maybe even do it once more, not as dramatically. Oh, I shouldn't have taken the points out. Yeah, a lot of this is just fiddling, and thank you for your patience, guys. But I think we're all learning a lot here.
Yeah, this is good. Yeah, this is good. It's
Um,
great while looking over someone's shoulder.
all
You know,
right,
when you click on the image, I'm noticing for an RGB image, it shows you multiple lines.
It does. It'll show you each channel.
Yeah.
Yeah, exactly. It shows you each channel if it's in RGB mode, which is convenient.
Look what it says, RGB and then gray. That's probably,
That's the luminance.
yeah, that was the, I'm wondering why it didn't work just with the luminance by itself. But anyway, hold on, let me turn off this extra little curves. I think it looks better with it applied, a little more contrast. Let's keep, I'm on the fence. I wonder if I can cut this in half. All right, look, I'll be here all night if
Yeah,
we,
yeah, no, then leave it on. That's what's
Yeah.
not.
if we nitpick, I'll be here all night. Okay, we'll leave it on. All right. So that's this one. All right, so let's get to the other one. The color image. So we're back on here somewhere. Where is it? Oh, look at this mess. All right, I'm going to clean up the desktop and just move all this stuff to another workspace. It's already confusing enough as it is. And just leave the stuff that we need here. Okay. We don't need this. We don't need that. Anything else? All right. Okay, so what do we want to do first here? Let's see. We already cropped. We're gonna try. We don't need to do deconvolution. Let's try the MMT attenuation here. So here are the presets that I have for the color. So we have 8 layers. I don't remember where I got this. Maybe from that page that John Rista had. I'm wondering what it would be like to apply this without the mask. I'm sure it's going to destroy the image, but let's just give it a preview here.
Which process is this one? What's it called?
The TVG denoise. This is actually the MMT. This is part of the. It's part of this script.
Oh, okay.
TVG
Part of the
denoise.
easy denoise.
Now look, without a mask, it actually did a pretty good job. Believe it or not, I'm surprised at how well the preview came out. Now it's kind of soft, but when we combine the luminance, that should fix that, right?
That should sharpen it up, right?
Yeah, it should.
Since because that was deconvoluted.
Yeah. All right. So how do I do that? All right. So let's. I'm gonna duplicate this so we have a copy of it, and we'll leave it here. Let me up the left-hand corner if we want to try this again, and we'll just apply the noise reduction here. Now, what I'm interested in trying is a couple different methods to stretch this. So let's try first arc sine stretch. Where is it? Here we go. So pull it up, we'll estimate a black point, and we'll look at all that wonderful noise. That's a little too much, I think.
Yeah.
Yeah, it's really green. You know what we didn't do? Shit.
We
gotta color
get rid of
calibrate
the
this.
background.
We got to color calibrate this.
Yeah.
We forgot that. All right. Let's do that first. All right, so color calibration. Let's see. I like to use the photometric color calibration.
I love that. I've really found that to work great.
Isn't it great?
Yeah, I wasn't using that at first when I first was playing with it, and then I started to use that. I don't do anything else anymore.
Is this the right designation? 6960? Is that the Western? Well, let's find out. Yeah, I used to do it the manual way too. Sometimes you're forced to do it.
Yeah, but for the most part, if you know, you can grab the data, a lot of the information, the image scale stuff right from the, oh, that's another reason for cooled cameras. The new cameras have all that data in there. All the image scale stuff is actually buried in the metadata, so you can just grab it from the camera.
Right.
But anyway, that's a minor point. But yeah, if it can find the image in the database, which it always has, it's worked really well.
I don't know what happened after like an update a year ago. Every time this pops up, red error, no database files have been selected. I don't know why. It finds it. It's looking. It's downloading it. Why is it got to do it each time? I don't know. Must be a setting that I messed up.
I know when I run mine, the default's in France. It's some database in France or something.
Yeah.
Strasbourg, that's the one he's using.
Is that what it is? Okay.
Yeah, you can see it in the first line of the Vizier data, Strasbourg.
Oh, I see. Yeah.
So I'm just wondering, I've used this before when I have narrowband data, but I want the star color to be accurate. So is that what you're doing here? Is you're basically taking where you have no color for the stars, or are you just trying to correct them in a color image?
No, right now I'm trying to correct.
Yeah.
And we might even
Work
correct.
to do it for when you have no color, you just have a grayscale. You convert the image to color from gray, and then you run the photometric. Does that work to get the star color right? I've tried it and I'm not confident that I've got it working.
I've never
tried that either.
I've
Yeah.
never attempted that.
I've only done it with the RGB data. Once I have the background corrected, I use that the dynamic background extraction, and then I also do I also get rid of the green cast by doing
SCNR?
by basically doing a linear fit of the green data to the blue and the red channel.
Oh,
It works really well to get rid of any color cast. I do that first, actually. I sort of crop it first just to get rid of the to get rid of the stacking artifact from dithering and stuff like that. And then I do that next, the linear fit with the green channel.
because you see what I'm saying? If you've got just narrowband data, you don't have RGB data to go with it.
Right.
You could do like HOO palette and create a nice image, but the stars aren't the right color. And so
Right. Yeah, they always have the color cast.
So I was thinking you take maybe the hydrogen channel stars, and extract them out, and then run this photometric color calibration on those to try to get accurate star colors for your HOO image.
It might work. Yeah, I haven't tried that, but I think it's a good approach. Because they always do look funky. The star colors on those narrow bands always look funky.
Yeah, and they should, because they're not
Right,
really looking at the entire color spectrum.
Right, exactly.
Now look at I don't like this. So that's a function of the stretching that we did.
Yeah.
I think we did this backwards. I should have color calibrated this first.
Right.
Oh man, I hate wasting your guys' time. I hate to waste time, but shit.
Well, we get the point.
Yeah. Let me see what's multi-scale media transfer. What's the next one? Okay. So we can go back to here. All right, now we color calibrate it. This shouldn't take too long, right? And then we'll just run.
Yeah, it's pretty fast.
Yeah, and we have the MMT on the other side, so we can just pull that over. Let's see how that works. Yeah, it's moving.
Does anybody know if this star registration survives a pixel math operation? In other words, if you have you've plate solved basically, and then you do a pixel math and you combine two images, does that zap out the registration that you did?
I don't know for sure. I wouldn't think that it would, because your image scale is still the same.
Yeah, I would think that it shouldn't wipe it out, but I haven't really
Never-
tested that.
Yeah, I've never tried that. I've never tried that after pixel math.
Because I like to do the plate solving and save that information. So as a part of my record of the process, I know exactly where I was pointing and what the camera rotation was. In case I'm going to work on multiple dates on the same object.
Right,
But also
right.
because then it's easy just in the rendering script to just annotate what you've got in the image. And that's sometimes nice to do.
Yeah,
Oh,
yeah.
shit. I know what the problem is, guys. The same thing happened again. And I think it's a problem with PixInsight with using the screen stretch function while you're doing this whole thing. So if we just go backwards one step and leave it. The same thing happens with the scripts when you're using the scripts, by the way. So we'll go back this way. Okay, so so we went to color calibration, and then we'll apply this, and then we'll stretch to recombine. Now, did we? I don't remember. Did we try the arc sign stretch the last time?
Yeah, that was, I think you did.
All right.
Yes, you did.
Yeah, that was the one where it went too far initially. When you found the black point first.
Right, okay. So there we go. All right, so let's try that then. There's banding on this. We forgot to get rid of the banding. So let's get rid of the banding now that we're here. Can you guys see that from, is it showing through on YouTube? The Canon banding?
Yeah,
I can see a little bit.
It's
yeah,
pretty bad, isn't it?
it's noticeable.
All right, is that better? I think it's a little better.
It is a little better, yeah.
All right, still a little noisy. All right, this is the cleanest got this pig so far. So you guys are helping me out a lot here. Okay, so now we'll stretch this with arc sign stretch. Estimate black point. This is definitely better. I don't know if we want all this. Let's put it back here. Boy, it's really noisy.
How much integration time is on this one?
5 hours.
Oh, wow.
Can you believe that?
This is from your observatory, your backyard?
Yeah, 5. This is the shittiest image I've ever gotten for 5 hours of data.
Was it recent data, like it was warm?
This 2 weeks ago. The dates, yeah, July.
Yeah, so it was hot, yeah.
Yeah, it was hot. It was hot. Yeah. So we can just go with this. Let's try that. All right. So we're at. I'm going to write this down. 90.2, and we're at 2844. 002844. Okay, so I'm writing down these numbers here. And we'll try to stretch it the other way. Let's try to stretch it the histogram transformation way. I'm already not liking it. Terrible. Well, why don't we just forget that part? And we'll leave this. Okay, so now we're stretched. And I'm going to move both of these to a clean desktop because this is a big mess. Or actually, let me move. No, you know what? Because I want the process consoles. We can close this down. We can close this. We'll open these up again if we need them. We don't need this anymore. We don't need this anymore. Okay. All right. So we can combine these using pixel math, or we can do the LRG. And we'll pick the, oh, look, I already put the right one on there. And then if we move the saturation down a little bit, let's see what it adds. Ooh, wrong. Did I add it to the wrong image? Yes, I did. What am I doing wrong here?
You should be.
Something's wrong. All right, let's
Is
just,
that, is the image you're picking, is it the starless one?
no, it's,
Why are the stars going away when you apply it?
yeah, hold on a minute. You're right. You know what?
I think you grabbed the starless.
We
one.
forgot to add the stars back.
Yeah, yeah.
I'm getting old, guys. I'm sorry. My memory's not the same.
It's okay.
Where's the start? No, which one is the one we wanted to use? It's not this one. It's this one, isn't it?
There you go.
Star Mask 1, and we're on desktop number 2, workspace number 2. Okay.
You know what I've wound up doing just as a to avoid confusion with my P brain sometimes
What's
is
that?
if you right click on if you go to the properties of the image, you can change like the one that it assigns, like it says gray, you know, with the scale Star Mask L. I've actually been you can edit that. It's called an image identifier.
Right. Yeah. Yeah. Yeah.
And then I just put in stars only, you know, use this.
Right. Right. I forgot.
I do
to
that all
on
the time. I do the same
Yeah.
thing.
Yeah.
I forgot to do that on this one.
Or, you know, starless image, blah, blah, blah.
Well, I'm happy with it. Star Mask 1, but we're gonna add it together now with Pixel Math.
Yeah. No. You know what I mean.
Yeah, exactly. Yeah, these little tips and tricks definitely help. Where's Pixel Math? Come on. Element OP. Here we go. Okay, Star Mask. Yeah, this definitely helps to have the name right with Pixel Math.
Right, exactly, because you got to stretch it all the way over to even see what it is.
Yeah. Where the hell is it? I can't stretch anymore.
Well, make the window
There we go.
make the window bigger on the other side.
Oh, we got it. Here we go.
Oh, there you
So we
go.
got Star Mask.
I see some people, if they're doing this, they'll actually just name the red channel R, just the letter R, not a really long name. It helps for like an intermediate file. When I save the file, I want to have all the information about it. So I have the long name, but for an intermediate, just use the shortest name you can.
Yeah, no, that makes sense.
Okay. We're back in business. Now, for those of you who've never used this software before, I hope we've thoroughly confused you.
No, actually, you haven't.
I hope we haven't confused you, but
No, you haven't.
we
I
have.
don't know how many times Tracy has heard me say this software is fantastic. I'm so impressed with the it obviously there's a learning curve like anything, but compared to anything else I've used, it just is incredibly powerful, and I feel like for the first time I can really predict what I'm going to get.
Right. Okay, here we go.
And I think it's like, I'm not really diving deep into some of the more esoteric power of it, but so you can, without learning everything about it, you can still get some nice results.
For
And
sure.
then as time goes on, you can add more sort of tricks to your repertoire. But there's so much depth to this. I haven't come close to plumbing all the things you can do with this. It's insane.
Yeah, same here.
I think at my peak, I only knew 10% of what this could do. I
Well,
probably
Another thing is
forgotten
I
more
mean-
than I've learned.
I've spent a boatload of time this year just going through the last 3 years worth. I've been doing this for 3 years, the last 3 years worth of data. And even since the beginning of the year, I'm getting better images from the old data than I was just even at the beginning of the year. So it's like all this data I have, I'm discovering there's a lot more there just because as I get through the learning curve on this software, you can just get more and more out of data that's just sitting in your archive.
Hey,
Yeah.
the more we do this, guys, the more, maybe next week somebody else could process, or next month somebody else will do. So, I mean, we're all learning a little bit of something here. But,
Yeah, definitely. I like the fact that the way the paradigm works with the software, that you can save instances of your process tools with settings that you like.
Yes.
right.
And then you
Exactly.
just use those are your new starting point rather than the default settings.
Right.
And it's not that the default settings are bad. They're better than any other software I've used in terms of the defaults. But once you tweak it a little bit, you can just save that as an instance of your process icon, and then you just pull that as your starting point.
Right.
Yeah.
I mean,
Yeah.
so I have them relate, like this one's a high attenuation. I have another one that's for RGB, another one just for black and white, another one for I have two adaptive stretches for whatever presets they were. I guess I should better. Oh no, it's one of them. One's the arc as long as you name this one is for nonlinear noise reduction, whatever, you can name them whatever you want,
Right.
whatever your starting point is over here. But anyway, what I was doing here with the LRGB, so first I tried to combine the two together with this box unchecked. And I decreased the saturation to get it, a little more color to pop up. And, so we'll try this. And if we like it, it's a little bit red, but it is noisy. We can click the Chrominance noise reduction and do it again. And this takes a little bit longer. Maybe I'll back off a little bit on the color there. And we can always use the SCNR tool later, I think.
We get rid of the red cast.
Yeah, and let's see if it. Ooh, I don't know if. What do you guys think that looks worse or better?
You're losing some of that detail.
Well, I'm gaining.
Oh, actually, no, never mind, because it's still some noise in the background.
Yeah, that's the problem. When I'm getting the detail back, I'm getting the noise.
Yeah.
And you're right. There's no. All the detail is gone here, and I put the luminance image back. So let me try, rather than doing that, let's try this at exactly 50-50 and see what happens. Maybe it's better this way. All right, let's try with the noise reduction. I'm still trying to polish the turd. The other thing I was thinking we can do, we can do one more passive noise reduction just on this alone. If it's worth it, we'll see here. We lose a lot. You know what? The mask definitely makes the difference. So why don't we just use that is the mask. Hold on, let's Share the mask again. What do we want? We want the, what the hell do we want masked? We want the nebula to show through, right?
Right.
Because the problem, is that correct? Hold on. What,
I think so, yeah.
show mask, the nebula, is that showing through or not? Mask, invert mask. See, this is hard to tell.
Right. That's
Uh,
the problem I have with the way they show the mask.
yeah, it looks like the nebula is masked here. So let's do it the other way than mask. Invert, but here, you know, maybe because it's so thin. But let's try it.
It's probably because it's faint.
Right. Let's just try it and see what happens. We're still losing way too much.
Yeah,
I'll
but the noises performance is better.
yeah,
The background.
yeah, you're right. I mean, we get the picture, right? I mean, we're
Hey, guys, I just recently was really starting to use the LRGB combination. And so I have a Gamma Cygni with narrowband that I have just a sort of a deck showing the process that I did. I was just wondering if I could get your feedback on especially the later steps.
sure.
Would that be okay to do at this point? I'm just asking.
I mean, do you guys want to see? I was going to show you the finished mosaic.
Yeah. Why don't you just show that, and then we could go to your thing, Mark.
Yeah. So I'll show you. I'm not going to go through any of the steps. The mosaic is making a mosaic. Is you think this is confusing? That's a real pain in the ass. But you know what? I'm going to leave this like this. Let's try get to use the SCNR. I actually have a red already set up here. And I never used 100% of this. But I don't know how much I like to use red because red is what we're trying to get. You know, and I think red is not.
I use SCNR whenever I get green, I'll use it.
Yes.
And if I get magenta, I'll invert the image and use it SCNR on green, and that'll remove magenta. So that's the sort of the two ways that I use it to remove green and magenta.
So how would you invert it here?
You just select the image, go up to the image menu and choose invert.
Here.
Yeah, up there, invert.
And
then when you apply SCNR, it actually removes but remove green, not red.
Right.
Leave it at the default green. It's a neat trick I learned from Bill Halligan.
oh yeah, I remember that. Now that you mention it, and then we go back and invert it again.
Yeah, and then invert it, and you know you've got what 49% reduction. Maybe you do it a couple of times, but that's the
I
idea.
don't know. That improved it.
Yeah,
I like
magenta
that.
and green just don't really belong in your images.
I like that. I mean, it definitely looks better. And look, we were able to keep. We got some of the detail of the luminance here. I mean, this definitely could use a better camera. Or the other thing I could do is I can collect another 10 hours of data or buy a camera. But, I mean, that's anyway. All right, I like that, Mark. That's an interesting. That's a cool trick. I remember
is a
Bill
good
talking
trick.
about that. And I never used
I
it.
never thought of that, where you basically invert it to get the complement, and then get rid of the complement.
You know,
Yeah.
what we should have done, and what we didn't do when we had the star mask was where is this? Wherever the star mask. Well, we could have done this. Wherever I don't remember where the star mask was. It's not it. What we could have done was added the star mask to this and then done morphological transformation to decrease the stars that way as well. That's just another, oh, here it is. Here's the star mask. Which one do we want? We want this one. What do we want this one? Let's try this one. This one here. All right, Control K. Easy, we know we have the right mask. And now we're gonna go to morphological transformation, wherever that is. I'll just find it here. And we'll do it 3 iterations of this. And let's see how that turns out.
You're going to use that to reduce the star size?
Yeah, it reduced them a little bit. Here's
Yeah.
yours
Yeah.
before, yours after. It also
Looks like
reduced
you're using a 5x5,
7.
7.
Yeah, let's try
Oh, I see. Yeah. Never mind. Yeah, you got the black going all the way around. Yeah.
let's try this one. Whereas before, I think 7 might work a little bit better.
Yeah, that's bringing 5 seems to be bringing it down too much.
Yeah, 7. Well, I think that's a happy medium. And then I would do one final noise correction using, ACDNR. Again, with this image, it's just a freaking mess. I'm not even sure if it's worth it. All the noise. All right, so let me show you the combined mosaic. Then we can go through that process another time. Okay. So file. Let's see if we open. Oops. Where is it? I have to find the file. If you give me 1 second here, sift through my hard drive. All this hard drive space. I love having hard drive space. Western Vale. Oh, you know what? It's in the middle of doing this. Can't do too many things at once. There's the one side. This one's even noisier. And that's the wrong file too. So to make the mosaic, basically what you have to do is register them how they'll be on a template. It's a little bit of a pain in the ass. If you guys have ever done this before.
I have not tried that. No.
Are you using Starline to do that?
There's a couple different tools, and I don't want to mislead you or misguide you, but you have to use the star alignment. You have to use I use the script, the DNA linear fit to get the areas that combine together, or that cross over closer in brightness. I know I have the final image here somewhere. I am not organized at all. I'm embarrassed to say here. One of these folders here. Is it this one here? Nope. I forgot where I put it. I was just looking at it before we started our session today, of course. And anyway, I guess I'm sorry, I promised you that I'll show you that, but maybe that'll be for the next time. All right,
That's fine.
so this was the first attempt, my first attempt at processing this mess. And clearly what we just did, this image is better for sure than my first attempt. But anyways, all right, it's all yours, Mark. You can, whatever you wanted to show us. You can have the screen back.
Well, thanks, Lou. Thanks for doing that. Thanks for showing that workflow.
Sure, I'm sorry that I'm not more organized.
Yeah, it's fine. I definitely learned some tricks, which is good. I'm only 2 months into fixing sites, so I'm still a newbie.
Well, I'm waiting for you guys to teach me more because I learned more today than I can remember. I hope I remember everything I learned. If as long as we keep doing this, we'll stay current, you know.
There's a guy, Warren Keller, who literally
Yes.
wrote the book on PixInsight. And I was going to take his PixInsight class up in Buffalo, New York.
Right.
Fortunately, it was in March of 2020. So you can imagine that didn't happen.
Right.
They canceled it. And so, but he now has a set of online classes you can buy. And I've been really kind of meaning to do that because I figured there's so much more to learn about PixInsight. So that's one thing you could do is, I don't know what the website is exactly, but I think if you just searched on Warren Keller, you would find a path to his website where you could take a PixInsight class online.
Yeah, I have his book. And you know what I was thinking about doing, and this year COVID screwed us, but you know, during NEAF, they have like a 2 or 3 days prior to that, a NEAC.
Yeah.
If you guys want to go next year, you know, I'm there with you.
I'm planning to go. I've got it on my calendar.
Yeah, I'm there with you.
I was going to go in 2020 and obviously that didn't happen either. So that would have been my first time. So, yeah, the pandemic kind of put a kink in my learning curve.
Right. Well, you did fine with on your own. I'll tell you that.
So let me just show you this. I just recently processed. This is data from August 12 and 13. I did 24 by 5 minute exposures with the actually it's the L Extreme, not the Enhance, HAO3 dual band narrowband filter. And then I did the next night the sulfur, the S2. And I never really processed all, you know, this way before. It was sort of something I've learned from some other guys. So I'm just going to quick go through what I did. So the first thing, this is the raw hydrogen data right here. So what I do is I took the data from all the light images and I process an Astropixel processor. And one thing you can do is if you have dual band data, you can say, I don't want a color image. I want just the monochrome H alpha channel output as a stack. So you can basically create from one set of color images, both the HA stack and the O3 stack. So that's what I did. So this is
say that again, Mark.
When you collect the data with the narrowband filter, it just allows sort of those two frequencies to come through. It's narrowband.
Okay.
And what Astropixel processor will do is you can say when you choose ready to integrate the stack, you can say, I only want to output in a monochrome format, the hydrogen alpha channel.
Oh, so you can do these separately, individually.
You can create the separate channels in monochrome. And then same thing with your S2 filter. You can get a color image out of it when you do the stack, but I don't want the color image. I just want to show a monochrome of the S2 data. And so you can basically create then the 3 monochrome stacks using a one-shot color camera, using these 2 filters. So it's like you reduce your integration time by having the color camera at the expense, of course, of giving up some resolution because you got the RGB matrix going on, not just monochrome. So,
So
So
that
anyway.
means you can process them separately. So if you want the certain sulfur data to come out more than the hydrogen
Yeah,
alpha.
yeah. For example, this image here is hydrogen alpha. And from the same set of lights, I got this image, which is the oxygen 3. So it's the same light frames produce both. But when I did the integration, I just focused on one channel versus the other.
Gotcha.
And this is done with the L extreme?
Yes.
Okay.
Yep. And then I have an S2 filter. And this is that. And you'll see it rotated because I wasn't paying attention when I did the hydrogen alpha. I didn't have the camera rotation where I wanted it. So I had to crop this image. But anyway, so those are the originals. And so then when I register, you can see with the hydrogen alpha, I had to rotate in order to register with the sulfur. And then this is the O3, and then the sulfur.
I love the crescent down on the bottom right.
That's why I chose it this way, because I was cropping out the crescent if I didn't use the sulfur as the reference frame for the star alignment. And so then, and then this is the O3. And then, so these are all now cropped. So then what I did is I created a luminance channel from the H3. And I also did the, what is it, MMT process. So I did basically the, oh shoot, what is star extraction first, and then the MMT, and then the histogram stretch. And that's how I created this, basically a luminance channel of just the nebula. And then from the same hydrogen alpha, I just created this, this monochrome channel for the hydrogen alpha without doing the smoothing, without the MMT. And then this is star extraction on the O3 and the S2. So then I did and those were all with the histogram transform. And then I just did a curves just to get a little more contrast in the HA monochrome and the O3 monochrome and the S2 monochrome. And then I did my histogram stretch on the stars. Just so this is how I'm going to put the stars back in. In this case, I didn't do anything to put color in the stars. I'm just going to leave them white.
Oh.
And so then I did the LRGB process here. So you can see I've got my luminance channel was that MMT processed hydrogen alpha. And then the R, I did the hydrogen, the G, I did the sulfur, and the blue is the oxygen. And in this case, I found I wasn't happy with the colors, so I just dialed back the green and the blue a little bit here, and I'm still playing around with this part right here. And so when I ran that, this is what I got for the nebula without the stars added back. So I guess at this point, I'd be interested in your comments about this. I
love
not
the depth
sure.
in the.
I mean, I think it's got a lot of detail to the using the luminance channel in this way. I think really helped me because you could see the oxygen and the sulfur were pretty grainy because they're really faint. And so I think I sort of eliminated any graininess from those channels by using the luminance. I'm not sure why it's so orange. I mean, I wouldn't have expected it to be orange like this. So maybe I need to play around more with the color channels and the weightings. But when I did then a curves transform on this, didn't make a big difference. In fact, I can't see any difference. Wonder if I didn't put the right photo in here.
No, do that again. Go back and forth.
Hey,
again.
Mark.
Yeah.
Hey, this is Dan. I'm confused. Was this done with a mono camera?
No, this is a OSC. It's a one-shot color.
And how did you get HA and O3 and S2 from a color camera?
Well, what happens is when you have the dual band filter on a color camera, it actually saves a color image. If you just looked at the image and processed it like it was a normal RGB image, you'd have a color image. And so what in the AstroPixel processor, it basically uses the frequency, the color. It knows which color is hydrogen, which color is oxygen. And so it can extract those out to be separate channels. So you can basically sort of get two for the price of one. You get two monochrome channels in narrowband with just one set of lights.
Huh.
Yeah,
I've
but I
never
mean,
heard of
like
that.
I said, you don't have the resolution, and a monochrome camera, there's no RGB matrix, so every pixel is recording whatever channel whatever filter you're using at the time. So it's a compromise. I don't have a mono camera right now, so this is the only way I can do narrowband.
Okay, yeah, I never heard of that. That sounds interesting.
Yeah.
Mark, is there a similar function, like a filtering function in PixInsight, or do you need to use Astropixel processor for this?
I honestly don't know the answer to that. My mentor, who I kind of really got kicked off in this hobby, this is the software that he uses. And so I sort of, just from the beginning, back in 2019, I learned to use Astropixel processor, and I think he still uses that for doing his stacking. I think it's a little easier, faster than trying to do it in PixInsight. Less monkey business, a lot of using just the default settings, and it kind of does it all at once. I mean, in one step, it does the calibration frames, it does the registration, it does the alignment, it does the normalization, and it does the integration all in one step. And you don't have to create folders with intermediate files of all that. And maybe there are more efficient ways to do it in PixInsight, but I've just always used Astropixel processor. So I don't know about extracting out the channels. I mean, I can show you right here. If I just go back, I think I have to share a different. Can you see, did my screen change to a different program?
No.
This is same one.
Same one. Okay, so let me just.
I think you can extract the channels from PixInsight. You should be able to.
So now do you see my Astropixel processor?
Yes.
Yeah.
So if you go to the raw fits, I use the adaptive array disk algorithm usually for my RGB images, but you can see there's this option down here for an HAO3 extract the hydrogen alpha, HAO3 extract O3 sulfur 2. So for these different filters, it basically has a setting for the algorithm to just pull out the data that you want.
I see.
I loaded that onto my computer, the Astropixel processor, and I didn't know where to start. And I started watching some funny
this
YouTube
is the main
tutorials.
screen right here, where you basically say, oh, these, put in your lights, put in your flats, your darks, or your masters, and you just load them in here. And then there's a place to just create the name you're going to call the stack. And then the calibration, analyze stars, registration, normalize, and integrate. I pretty much just use the default settings on all these, and then just click on the integrate button.
Have you tried the one in PixInsight?
I've dabbled with
processing?
it. I've dabbled with it once or twice, not to the point where I feel I'm confident I know what I'm doing. I think I've used some of these just because I needed to in PixInsight. I can't remember the reason why. Something I was doing in PixInsight when I needed to do a star alignment or something. I've done that independently. I've tried to do mosaics in PixInsight, but I haven't really turned the corner on the learning curve on that yet. So anyway,
Well, the
and
more
then to finish up, what I did is I did remove some of the magenta with that trick I was telling you about, where I did invert, SCNR, invert. And I did bump up the saturation a little bit. Oh, I did do color calibration of the stars. So this is the monochrome stars. You can see I did manage to get some yellow in Seder here.
oh, right.
So that's the photometric color calibration. I forgot I did that. And then I combined the two together, and that's the final result.
So Mark, if you're asking me, if you go back go back a couple, let's see here, to the LRGB color nebula number 19. What's the one, number 18?
Oh, 18, yep.
Nope, 19 is the one I was looking at. The first one you showed us and you stopped. And I think this was this one. You know, it's a little bit pink on the bottom where where the crescent is, and then the bottom.
Yeah, I
outer
know,
pink.
I know.
I love that depth. I mean, the pink and the orange. I know you were complaining about the color, but it gives it a 3D type of effect. I don't know. As soon as I saw it, it grabbed my eye. I really like. I would have stopped here and added the stars from here, I guess. But
Yeah, and I don't disagree with that. I'm just saying it's more like, not that I'm unhappy, but I was just surprised I got this orange color. Because the other HOO, well, I guess I haven't done HSO hardly ever, so maybe that's it. The sulfur is just because it seems like the sulfur is actually a fairly strong channel. I mean, if you just look at the sulfur stack here, there's a lot of sulfur in there. Whereas the oxygen seems the least of the three. And of course, hydrogen is the strongest.
it's just beautiful data all the way, everything, the image, everything, all the way around.
I like the dust clouds too,
Oh,
where
yeah.
you got the dark areas.
So, what focal length were you using for this? Was this your Red Cat?
This is my red cat. Yep.
How much did that cost you?
I think the red cat is what about 1,600 or something like that, is it?
Now, is that a doublet or a triplet? The Red Cat
Triplet, I'm pretty sure.
is it?
Yeah,
I'm
Okay.
not sure. Don't
is.
take my word on it.
it is. It is.
Yeah.
So and it's $1,400. I'm wondering if I should buy this rather than a
I
camera.
haven't looked recently, but I think that was about that. I bought it in January of
There's
this
just
year.
Too many things to buy now. Maybe I shouldn't have any more of these workshops.
And this with the ZWO ASI 2600 MC Pro.
Yeah, right. That's what I'm saying. Like, what do I buy first? I guess I need a camera first.
I would get the camera.
Yeah.
If you want a small refractor, I can lend you one.
There's the thing. I don't know the first thing about refractor, so there'd be a whole new learning curve.
Well, honestly, this Red Cat 51 was the easiest telescope to learn to shoot.
Really.
Oh yeah, my Schmidt Cassegrain, I've taken over a year to just figure out how to use it. Because it's such high power magnification. There's much more demanding on all the details.
Yeah.
Whereas the Red Cat is just
on.
from a focusing standpoint, from a guiding standpoint, it's just easy peasy.
Well, what I've discovered in my journey here, data collection and all that stuff, it's, you have to know, obviously, both processing and data, but maybe like 10 to 20% of my energy goes toward data collection. A lot of, all the shit's automated, right? Once you have everything set up, and basically, once you learn polar alignment and, the fundamentals, you can use the scripts and everything is automatic.
Well, what really lifted my game was, I mean, the ASI Air is convenient, but the things that really changed was plate solving. Using the plate solving for alignment, for polar and star alignment, was huge. And then also having the electronic focuser, and the autofocus routine in the ASI Air. Those two things gave me, and of course, once I got the guiding working, then I mean, I'm taking hours of data where some nights I'm not tossing out a single frame. I mean, it's just rock solid. So
Yeah. I found the same experience with the ASI Air.
yeah.
It's just been wonderful I love that you could just, if I want to frame it a little differently, I can just move the little box over in K-stars and then just say center here, and then it plate styles, and then you can hear the mount just boop, 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 you know, and then all of a sudden it's exactly the way you wanted it framed.
So
Right.
you're referring to the feature in the ASI Air where you can look at how you're framed and it superimposes from the database, the background about what you're shooting at?
Well, it's basically plate solving based on the on you giving it a target from the built-in planetarium software, K-stars that it runs.
Yeah, okay, I didn't know that it was K-stars that's running on the ASI Air.
Yeah, they're running K-stars in the back as, you know, one of the open source planetarium
Yeah,
software.
it can be really useful. It saved my butt sometimes where I keyed in the wrong coordinates and it was pointing at a different part of the sky. And if I had have checked, it would have shown, well, I don't have that object framed. It's just, I better double check where I'm pointed. Because for a dim object, sometimes you really can't tell for sure unless you really know the sky, whether
Right.
you're not in the right place in the sky, because just one frame doesn't really show the object very clearly. So.
Right. No, exactly. Yeah, because even when I do a preview frame for like a minute or two, you know, if it's a dim object, you can barely see it sometimes.
Yeah, like the Witch Head or Shark Nebula, those are just really
Right.
hard to see.
Is the ASI Air hardware or software?
It's
It's a Raspberry
hardware.
Pi computer. It runs Linux operating system, and it basically completely runs your scope, and then you just control it with a remote user interface on your iPhone or your Android or your iPad. And if you have one of the newer Mac laptops with the M1 chip, you can actually run it native on there and control it from your laptop.
Okay, I use Nina, so I'm not familiar with
Yeah,
that.
Nina's great. A lot of people use Nina. This is kind of Nina light, I would say, because it doesn't have all the bells and whistles, but it makes it simpler. There's just fewer things to do.
Yeah, the thing that blew me away was just how productive I can be now, like in terms of target acquisition. It's just that overhead has gone from, you know, an hour or maybe 40 minutes of finding it, centering it, doing the blah, 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 you know, focusing, re-guiding to literally minutes now. I mean, it's five or like polar alignment typically takes me two or three. If it's a bad night, if I'm struggling with it for some reason, like I overshot too many times, it's 5 minutes. And it's down to like, 30 arc seconds or something.
Right.
Yep, exactly. The thing also about the ASI Air that I like, it gets my laptop out of the condensation, out of the dew in the field.
Exactly.
I don't have any USB cable, running from the telescope to a laptop inside a cardboard box or something like that.
Exactly.
So I actually have a cigarette lighter output in my Jeep with a AC converter that I just plug a Wi-Fi repeater into that inside the Jeep. And that's strong enough to pick up the Wi-Fi from the telescope outside. And I can just sit in the Jeep or in my camper, if I'm in my camper, and just run everything from inside rather than having to sit out in the cold.
That's a good idea. I'll talk to you more about that some other time with the repeater, because I had looked into setting that up, but I haven't done it yet.
Yeah,
It works pretty slick.
I have mine set up for total wireless control from inside the house, or if I go out in the field, I could sit in my van and do whatever I want.
Yeah.
Running it with, I have an 18-inch tablet, which I'm using right now for this session. I use that set up with Sky Safari Pro so that I can decide on targets or whatever. Plus, it's also linked into the Wi-Fi signal that the repeater's throwing out. And I use a 10-inch tablet for controlling, the ASI Air and the camera and scope. So it works out really well for me.
Yeah, I often have my Red Cat and my Schmidt Cassegrain going at the same time. And I can do station mode on the Wi-Fi repeater from both ASI Airs. And then I can just switch back and forth between the two setups on my my iPhone or my iPad.
Yeah, as far as your dim target acquisition, what you should do, and I've done this a few times with the same problem, is I'll just run, like a live stack for maybe 25 images or something, but I'm doing everything sub 30 seconds. So it's only a few minutes, but I can then adjust the framing as far as fine tuning it, and centering it the way I want, and then go back to running an auto run.
Interesting.
That's the one thing. Once you got the image acquisition down, there's so many tools to help us with I think 80% of our energy should be going towards processing. That's the biggest learning curve, I think, because shit's always being updated and new features being added.
Yeah.
But
It's been, I tell you, with PixInsight though, it's brought the joy back to it for me, because I was struggling so much with, I started with Photoshop 20 years ago or 25 years ago. And then, I tried like Nebulosity, and then have settled on Images Plus. And Images Plus is very powerful, but it just wasn't as well organized as PixInsight in terms of how the tools were structured. And then it stopped getting maintained. So for me, it started to become a burden to process the images. Now with PixInsight, it's like fun again. Which is
I love
cool, to actually start to look forward to processing again, because I was starting to get to a point where, oh man, I got this data. Oh yeah, I guess I got to drudge through processing it.
You're right. To a point, Gary, I know I have folders upon folders of data pre-PixInsight I should probably go through. I never really got good at Photoshop using it, but it's cumbersome to use.
Oh yeah. I mean, my first class was with Jerry Rodriguez at NEAF, 20 years ago, doing all this stuff with Photoshop. And, it's incredibly laborious.
Yeah. With Photoshop.
But it's incredibly, stacking I used to do as layers in Photoshop with progressively less weighting. You take 1/n of whatever image layer it is.
What Photoshop reminds me of? You guys ever watched the New Yankee Workshop?
I've seen it, yeah.
With Norm,
years ago.
Yeah, working with a jack plane rather than a power planer.
Well, he would make a jig to make a pattern, to make another jig, to make a pattern, to make a piece that he used to cut out a pattern for the jig that he needed for the part. That he made 16 different tools out of before he could even get the when he needed to fit the piece. And that kind of reminds me of Photoshop, because there's no direct way to do a lot of these things that we need to do.
Right.
But anyway, I found the merged mosaic.
Oh, cool.
It's I don't know if I shared it. I don't know if you can see it or not.
Yeah, it looks cool.
Yeah.
But I was going to show you some of the problems I came across. First of all, I didn't process the images the same way, so it's much noisier. This is another process I did on the one side, but when you smooth them together, you have little artifacts you got to worry about, like pinching here. So what I would do next is, if this data was good and I wanted to, if I had a cooled camera, in other words, the next images I would just collect would be this panel here, maybe this panel, and you can just all add to it. And the biggest thing with mosaics to remember is the gradients. The gradients are such a pain in the ass. It's not so big of a deal if you're using a long focal length, because the gradient's tiny, but if there's a gradient across the whole sky, but it does make a difference no matter what focal length you have, whether the moon's out, whether the there's clouds or whatever, your neighbor turns the light on.
Well, even Lou, if you're in the same location, what time of year? Because if
Exactly.
you have light pollution to the north and to the south, or the east versus west, then you'd have these gradients one time of the year that you wouldn't have the other time of the year.
The other problem too, and you're right, different times of the year, the object will be at different heights in the sky. So usually when I'm doing mosaics, what I would, when I'm shooting setting up the sequence, I would just mix them up. Like I would never do all of one side one night. I would start on, let's say, side one, and then, move to side two, then go back to side one, and then, maybe do 10 images of side one and 10 images of side two. And then the following night, maybe I'll start with side two and, reverse the order. But the other important thing, this is a couple things I forgot to mention that I wanted to point out. It might come in pretty handy, especially if you wanted to try to do a mosaic, is, what's his name? Is it Adam Block? He has this method. I know a lot of this happens during stacking where the images get normalized, but he has a technique where he normalizes his data independent of what the stack is doing, so that there's one gradient to remove at the end, rather than, stacking the different gradients together. So then you have a complex gradient, which is, I'm sure you guys have all kicked, the computer getting pissed off because you're going to get rid of the gradient. This can be frustrating, but that little trick that he used really saves a lot of trouble.
Lou, do you merge your mosaic when it's linear or after you've done some processing?
So this mosaic right now is completely unstretched.
Okay. Yeah, that's what I thought. I would figure you'd want to do all the histogram and curves and all that other stuff once you'd already merged it.
Yeah, this is all unstretched. So I could still, now I can go back and reprocess this as the single image using the same exact techniques we used before.
Yep.
I have different problems to deal with now. Now you see how these stars got pinched? That can be changed by using this tool here. When you combine, instead of, we can do overlay instead of average. And then that would matter which image is first. So let's try and see what happens. It'll just move the pinch mark, I think, to the other side. But damn, I'm still looking at this data and seeing how noisy it is. I'm not thrilled at all. So you guys don't think it'll be an issue if I get a camera with a 3.75 micron pixel pitch using a 1400 millimeter focal length?
I don't. I haven't seen any issue. My the C6 that I'm using, I hadn't gotten the field flattener focal reducer yet because they were back ordered for a couple months, and I wanted to try it anyway, and I wound up shooting it the native. It winds up being more like f11. It's 1732 millimeters if I plate solve it.
Oh.
And it's I mean, the stuff looks good to me. And now obviously there's, coma in on the edges and stuff like that, because I don't have a field flattener and the stars are kind of bloated. But from a coupling to the camera in terms of oversampling or anything like that, I'm just not seeing an issue.
Yeah, I've got the 9 1/4 inch, but I am using a 0.7 reducer. So I'm operating about 1610, 1640. And using the 3.76 micron 2600 camera works fine for me.
So this one here is the only one that ZWO-ASI makes that has a bigger, the pixel size is, where is it here? Well, look at that full well depth, 100,000.
We're not looking at your screen. We're still seeing Pix Insight.
Oh, sorry.
But yeah, what is it? The 294? Forget what the camera was. That's got a 4 something micron pixel size.
Yeah, hold on, let me find this here. Here, you see it now?
Yes.
So look at this. I didn't even read all the specs on this. Joe Lamb pointed this out to me earlier. But I was wondering, I was going to pick this camera up.
2400?
Yeah, but look at the price.
Oh, yeah.
$3,500. It is
Yeah,
full
it's
frame. I don't know if I want a full frame, but it goes down 35 degrees C. It's 14-bit.
I think with your C, you'd still use it with your C8
Yeah, I mean, because
you're probably gonna vignette like crazy because that visual back is small on a C8.
yeah, you're right, and that's
You're
what
not you're, even with 2-inch focusers, with a full frame with 2-inch focusers, you're gonna have significant vignetting.
you're absolutely right, because this is a full frame. Even if I use and you're right, especially with the focal reducer, because that will make it even tighter. The VIN getting more obvious. So rather than
The 2600, I think it's on sale now for $17.90. I think it's $200 cheaper right now
Yeah.
for the 2600.
don't make me pull the trigger now.
No, I'm not saying you should, but they're.
I'm so tempted right now. I mean,
They have about a $200 price reduction on a few of their cameras, and that's one of them.
so do I buy the mono or?
I mean, that's more a matter of how much time you want to, make collecting data. I did the one-shot color.
So this is the 2600. It's $1,700. Is that right?
Yeah. Yeah, it was
Well,
just when I
$17.95.
bought it at the end of last year, it was 2000.
And this is 16-bit.
Yeah,
Full well depth is still more than my DSLR.
it's 50,000, I think.
Yeah, my
well.
my DSLR is only like 32,000, which still isn't bad. But wow, if it's 50 grand, I'm gonna have a hard time. So Gary, let me ask you, when you're using this camera, on a bright object like M42, you shouldn't have any pixels being blown out, right? I mean, you should have the full dynamic
I mean,
range.
it depends. It depends on what, on how long you're integrating for. Like if I would still probably on something like M42, I would still probably do some graded exposures.
You think?
It's like when I went to Cherry Springs in May at the end of May, I was easily doing 10-minute subs with this camera. I mean, easily. I could I know I could have gone more. I was nowhere near in terms of background sky and stuff like that. It was the stuff was dark still.
Yeah. So the thing is, I know that with my DSLR, the full well depth is in the low 30,000s, and I was able to get pretty good dynamic range with M42 using one ISO, one gain setting. It still wasn't perfect. I definitely could have, it would have been improved if I would have used integrated two different gains or ISO in that case. But where this one has considerably more, almost twice the full well depth there, twice the dynamic range almost. I'm wondering if that would, and just for that one image, that would be a pretty good, I think a pretty good bellwether, at least for me, that I could understand hard and fast. Look, this bright object, is this camera capable of capturing the whole range, because we all know the center of the how bright the center of M42 is. It always blows
Yeah.
out in your
Oh,
images.
yeah.
And I'm wondering
Yeah,
if,
I haven't run that experiment. It was, by the time I got the camera and got everything up and running, it was too, it wasn't a favorable target anymore.
right,
But
if,
come this fall, or come this winter, I'll definitely try it again.
yeah, it's, one thing I like, that's, I don't know how, I like to look, the best way I like to learn is actually physically doing and comparing, something that I'm looking at. I know, and this object I've imaged M42 a zillion times, and each time I have the same problem with, the dynamic range. It'd be interesting to try it with another camera.
Yeah.
I'm just trying to, look, I think I'm just talking out loud, trying to convince myself to buy this camera. Like,
Well, I mean, there's other options too. If you want, they have one that's pretty nice. It's a 1-inch sensor, a little lower resolution, same full well depth. It's the model 533.
That's the one I'm
shot
buying.
color.
That's my next camera.
And it's $899, and I tell you, it's a hell of a lot of camera. It's a little smaller body,
oh,
so it doesn't have the it's not quite the payload hanging off the back of the telescope.
this one here. Can you still see my screen here? The 533. Oh, that's MM.
Yeah, it's the MC.
Where is it? 890. Because why is the mono more expensive?
They are, even with the 2600. The
Yeah.
MM is a couple $100 more.
Yeah, you're right. 899 here is $900. There it is.
1-inch sensor, same pitch, I think, or approximately the same pitch.
3.7. Yeah, it looks like everything is the same. Where's the other one?
It's just a smaller sensor. It's a 1-inch square rather
Right.
than an APS-C.
This is 14-bit. Was the other one
The other one's 16-bit.
16-bit?
They consider this more of an entry level camera, but a lot of the reviews that I've read, they said, you could call it that because of the price point, but it performs like a more advanced camera.
I don't know. I'm torn here now. I've seen what you guys have done with this with the 2600, and I'm tempted now. I'm really. Since you told me,
it's definitely worth thinking about. I like it. I mean, I really love it. It's made a difference for me. It just made the whole process better.
right. I'm just so upset with all that noise I got from the wait 5 hours, and that's 5 hours on each of those panels. That's 10 hours of data total that I wasted. Or I don't have I'm not going to get an image out of that.
Luke, question.
What's that?
Can you see me right now?
Yes, I can.
Okay, I'm going to turn my tablet around to face my laptop. Let me know if you see an image.
It's very bright, and it's just the top of it.
Let
Do you want to share the screen?
I can't because it's two separate devices.
Oh,
How about now?
no. I can only see the very, very top, and it's very bright. Oh, there you go. Oh, is that the crescent?
Yep.
You can barely see it.
Oh, sorry.
Can you move can you move it a little bit higher? The other way.
That's
Higher, higher. That's the other way. You had it. It looked good though.
Not the tablet, the image of the computer is
Yeah,
much
yeah.
higher. So point the tablet lower.
Say when.
Keep going.
Shit. Hang on.
Keep going.
I'm
There you-
almost on the deck of
There
the
you go.
laptop.
There you go.
And closer, maybe.
Let me see if I can get.
Remember where the camera is on the tablet. It's not in the center.
I can still see it. That's
That's better.
yeah, there you go.
All right, real quick.
Yes.
that is 25-second subs, 250 subs. They were taken the night of the 13th. The sensor temperature was up in the mid 80s.
The sensor temperature.
And
Let's see
that
that again.
image-
Put that back up.
Now, let me just give you the description. That was shot with an MC 385,
Okay.
385 MC, which is basically a beginner's camera. I got very little noise in that. What you're seeing around the edges was amp glow. Okay. But I think that, and what you saw on the computer screen, that is the original stack with just the auto stretch. I have done nothing to it yet.
Interesting. You know what? It's really hard to make out any details looking at that way.
Yeah.
Is there any way you can post it somewhere, like on the forum?
I don't know. I haven't been into the forum yet, but what I can probably, take that, get that file over there somehow.
Yeah, share it so we can all see it.
Yeah, I've done absolutely no processing on it whatsoever.
Now, what's this we're looking at?
So Lou, this
That's the
is
same thing.
This
It's
is
just
Eastern Vale. This was shot in my
that's
front
that's
yard.
a veil. That's the veil.
Yeah, right. I mean, whose computer? Who are we looking at here?
It's mine.
Gary.
It's Gary.
Okay.
I am.
Computer, shut up.
Okay.
So this is 60 minutes worth of data.
Okay, that's clean.
This
Yeah,
is
mine-
60 minutes shot in a Bortle 6 sky with haze that night.
Wow.
Yeah,
Gary,
my skies here are Bortle 7.5.
I was just curious to see what that camera would do. This is through my TV 101, so it's through a 4-inch refractor, shooting at about f4.5.
this is the ZWA ASI 2600
Yeah,
camera.
yeah.
Yeah, rub it in some more, Gary.
Well, just trying to show you what
No,
in
I know.
terms of the background.
I'm buying this camera. This is what I'm
I'll
buying.
tell you, you won't go wrong with the 533. 'Cause that's the one I'm getting next.
I mean, this is pretty impressive.
And this is me not knowing PixInsight that well. You can see a little bit of coma on the edges from the tube.
That's not from. Now, have you tried software binning, or is that a waste of time?
I haven't played with any binning yet, either software or hardware. I haven't tried that. I thought about that for really bright objects, because that, you can basically increase the effective well depth, right? If you spread those photons over multiple bins, but
My Air Pro,
I haven't tried that. I don't know if anyone else has.
my Air Pro defaults at bin 1, and that's where I'm shooting everything.
Now, what was the thing we had brought that up last time? Was it Gary? Did you bring it up? Or Mark wasn't here. We were looking for Mark to answer this question. Remember, Gary? Somebody had asked whether it was it Joe, Tom? I don't remember who, or the actual gain number that's on the ASI Air doesn't correlate exactly the same with on the camera.
No. It's different on the ASI Air app and what your gain settings are compared to what it is on SharpCap.
Right.
But all you have to do is turn it into percentages, and you can. And I don't know if you know Dave Barrett over at High Point Scientific.
Yeah, I know Dave. Yeah.
Okay, I've known Dave for 30 years, and he was telling me when I first got my camera, I was asking him what kind of gain settings he was using, because he uses the same identical camera I do.
Okay.
And in fact, he recommended that camera as, for getting started and having more camera than what we're really paying for. So basically what we did is he has his gain up around 300 or so, according to SharpCap. I use 172. in
So-
ASI air.
Oh, that's, all right, now you're not adjusting it from the camera, all right, so you're saying
doing-
the sharp
what we-
cap gain is higher than what the gain is on,
Well,
Yeah, yeah.
it's just a different scale. Like, for instance,
Right.
if you look at,
Scale.
if you look at the spec on something like the 2600 or the 485 or those cameras, if you look at the data sheet, the gain goes up to 450 on both
Right.
of those cameras. But sharp cap on the one goes up to like 100, and on the other one goes up to 300 or something. So you have to just sort of think of it as a linear,
what I'm asking is,
what proportion of the gain you're into. So like,
Yeah, just turn it into percentages.
what's the is there a standardized conversion factor? that
because it
why do
depends
they
on
do
the
it?
app. Like if I hook my 2600 to sharp cap, it goes up to 600,
Right,
but the camera spec only goes to 450.
okay,
So 600 is the equivalent of 450. So you would take that percentage.
is that the same factor for all cameras? Is that with sharp cap, and what about the, fire capture and all the other?
I
No-
think it
no
kind of
knowledge.
depends on the app, is my experience.
So that's curious why there would be so much variation, because that did cause.
I don't get it either. I think it's stupid. And I had never gotten a straight answer. Even when I asked the ASI, like when I asked the ZWO techs, I don't know. It seems stupid to me, but that's how it is.
It just seems like it would add more confusion, and like it did the last meeting we had. I couldn't answer. I didn't. Why would you do that? We have enough confusion as it is in the hobby. Let's
Yeah.
throw in another variable.
You know,
Well,
the
a lot of
advice,
things
the
work
advice I've
together.
gotten from more experienced astrophotographers than me is for deep space objects, you should just shoot at unity gain and forget about it. Because that's where one photon equals one electron volt or one electron
Oh,
unit.
don't you want? Hold on a minute, Mark. I don't know if don't. You got to make sure that the Unity. I mean, some cameras,
Right.
they change the
Unity
algorithm.
gain, where is that? Like on the 2600, it's at 150,
No, it's at 100, isn't it?
or maybe it's 100. I'd have to open the spec sheet.
Well, I mean,
if you look at
It is 100.
if you look in the spec, the read noise chart, where it shows read noise on the y-axis and gain on the x-axis, you'll see the read noise goes gradually down and then it has a big jump down at 100. And I
Right.
believe that's unity gain.
Right,
So-
it
That's
is.
true.
So
But
now
they're-
what
they're
is
not all
on
the same way
ASI
like that.
air?
And then that number is based on ZWO or
Yeah.
based on.
Yeah, they say it's gain unit 0.1 dB. So I'm not sure if that means it's in units of dB or I'm not sure how to interpret the units on that, but it's the spec of the camera on ZWO's website.
So that's
Right, gain.
Now, if you're using the ASI air,
right.
right, if you look at that chart, that same chart on the 2600, it goes to 450, where 100's unity gain.
Yeah.
If you pull up the 2600 MC on the ASI air, which is also a ZWO product, it doesn't go to 450. You can't set the gain to 450. So it goes to 300 or something. So where is the 100?
That's a good point. I had never noticed that.
My camera has a unity gain of 131.
That's
However,
the thing that's the question. Where is that? Is
Right.
it 131 setting it on ASI Air, or is it 131 using fire capture?
it's on the ASI Air app. It's at 131.
Right. So
Okay, but the thing is, with my chip, it actually gets less noise as you increase the gain. It's different. And then it's only up to a certain point, and then of course, you'll start getting a lot more noise. But I can go all the way up to about a little over 200 without getting too much noise.
Right. Sure.
where I'm confused.
Anyway, this is still a mystery to me. If anyone finds out the reality, what's really going on, like what correlates to what in terms of the spec sheet versus the app, I'm all ears.
Yeah. Because when they use okay, so some of the cameras I've noticed that when, the read noise drops dramatically right off at unity gain. Other cameras or other models, the unity gain is not in the exact spot, or it's at a different place where the read noise drops off. And as long as you're on the right side of the read noise, if that drops off, let's say at 100, I would like to dial that in at 101 to make sure that I'm not on the wrong side of the electronics. If I didn't go far enough, I want to be on the correct side of the curve.
Right, right, exactly.
I want to separate. But the problem that we're having is throughout all this, I can't know that unless I buy an ASI Air and to use their scale. I mean, is that why they did that?
No.
I don't even know if you would know it then.
Really?
Like I just plugged my camera in my 2600, and I'm on Sharp Cap right now.
Right.
Sharp Cap, the gain goes up to 700 on an ASI 2600 MC.
Okay.
Right.
Right.
That's Sharp Cap. According to the ASI 2600 spec sheet, the maximum gain is 450. So I don't know what that means. The 700 same as 450. If I pull up ASI Studio, which is, an ASI product, right?
Right.
It's the software that they give you with their camera. If I go to my 2600 and I go to gain, the gain goes up to 700, just like Sharp Cap.
How the hell do I know which side of the curve I'm on?
Well, that's what I did was I asked, Dave, who also uses the same camera, and he's been using it for a few years, so he had a lot of knowledge right there. And we just simply turned it into percentages, but you got to look at the scale for each app is independent to each app, not the camera.
Okay, so you're saying, Gary, that the ratio is 700 to 450.
I get it.
600.
That's what the guy explained last month. That's what he thought it was. I just opened up Fire Capture with my camera.
Okay.
Showing 700 is the maximum gain. So
Okay.
they all agree.
All right.
So Sharp Cap, ASI Studio, and Fire Capture all show the camera gain as being a maximum of 700.
ASI Studio. Okay, ASI Studio, Sharp Cap. The only thing that shows you 450 is the ASI Air. Correct?
Is the data
Yes.
book.
All right. So is that the number that these specs are based off on the website? Like if you go to the website, it'll tell you, hey, look, wherever the data jump is.
It's based on the 450. So for the 2600, unity gain is 100, is a gain of 100, and that's based on a scale of 450 with the max.
Okay, the 450. Whereas the other, so the third-party apps equate that to 700. The 450 is equal to 700.
Exactly.
All right, so
that seems reasonable.
All right.
So you take your maximum of each and then turn it into percentages.
Right. And
Well,
that sounds
I
so
don't know.
cumbersome.
I was just surfing some chatter on the internet. There's a lot of confusion about this. And some people are saying that for these cameras, you would never want to shoot it above 100. So if the gain reading says 100, that is the same as 100 on the ASI chart. There's no point in going above 100 for the gain. But
That
again,
would be
there's a
true
lot
for
of
the-
confusion and not everybody's saying the same thing.
But wait
So I
a
don't
minute.
put a lot of weight behind this.
Right. Right.
Yeah, I mean, but if you're using something like, Nina, for example, how do you set the gain on Nina? Do you set it to as if the top is 450 or as if the top is 700? Because
The chatter that I'm sort of following is saying that 100 is 100. Period.
So the top scale is just something outside of the range or whatever. It's still
Yeah.
maybe it flips
Oh,
maybe
it's
eclipses
completely irrelevant.
450.
Yeah, that
Oh.
100 is 100, no matter what software you're using.
All right, so that
That's-
clears up a lot,
Kidding.
but it also, why would they add the extra?
I don't know. Maybe that's just how the software is written. That's just the scale that they use.
So,
Mark, when you're doing the ASI Air, are you setting it for 100 on the app?
Yeah,
No,
I mean, I've been a back and forth on that, but that's where I'm at now.
Okay.
no, I've been, it depends on the target. For like M42, I drop it down to about 40 to 50 as far as gain, simply because I don't want to blow out the center. And I use shorter exposures.
Well,
Once
one
you get
thing
more
about
read,
that is
you get a lot
if-
more read noise though.
if
Right.
you use the HD high dynamic range tools, I've had good luck with not blowing out the center, even with just one set of lights for Orion. I mean, if you look at the unstretched image, yeah, there's maybe the very core of the nebula is white, and you can see that before you even stretch it. But with high dynamic range, you can get a lot more detail out. So I've not been doing multiple exposures on even things as bright as Orion.
Yeah, I do a lot less exposures too, but I did one back last fall, and I think I did like 20 exposures at a low gain, and 10
Well,
seconds instead
it's
of
not
20
the
or
number of
30.
exposures, it's the length of the exposure, which would really cause
Right.
it to blow out.
Yeah.
Oh, yeah, you want a lot of exposures, but you don't want them to be too long, or like you say, you just completely saturate the core and you lose information.
Okay, so here, take this for example, guys. Let me share my screen. Here's a confusion where I have. Let me
I'm
see.
going to need the bolt. Just
Take a look.
realizing what time it is. I'm wondering why I'm fading.
Oh, fuck, it's 11:30. I didn't think I was gonna stay here 2 hours. Here, really quick, take a look at, can you see my screen here?
Yeah.
Yeah.
All right, you see where unity gain is?
Here,
It's the last chart at the bottom,
the bottom chart where the little line is.
where it says read noise.
That's read noise. Unit, isn't,
No,
isn't,
It's in the read noise.
look, unity
see where
gain
the-
here is 1, right here, 210.
no, I don't, that's just
That-
gain 10.
Unity gain
Unity
is-
gain is, if you look at the read noise chart, where there's a sudden drop in read noise, that's unity gain.
No, unity gain is when you move up 1 electron, and that's where this is, right here, 210. There is where the confusion is. This is not unity gain right here. You're moving 4. It's taking 4 electrons to move 1 ADU. See that? See that? That's my question. This scale, we have to understand this scale in order for that to work. Because if you're on this side, you're gonna get a lot of freaking noise. And this, you're gonna go this far. Do you really need to go all the way to 210? I mean, maybe, I guess I suppose that you shouldn't go much further than that. Because the diminishing returns, but diminishing returns, I guess, start about here somewhere or here. I don't know. But this is not the only camera that's like this. I mean,
What
you guys,
camera is that, Lou? What are
What?
you looking at?
this is which one is this?
If-
The
if you
482.
do
The planetary camera. Okay,
Yes,
it's a planetary camera.
This is a planetary camera.
Yeah,
But
yeah.
it's not, yeah, I've seen this in other camera, and it's not the first time this question's popped up. And
Lou,
that's,
But if you look at the deep sky cameras, where you're taking longer exposures, like the planetary cameras, they design differently because they're designed to take short exposures basically. If you look at one of these, the breakpoints tend to be the same. Like look at that 533 or the 2600.
right,
The
okay,
2600 unity gain is 100.
Right.
right.
It is 100 so if you look at the specs for the 2600, that's the unity gain.
And it's the same for the 533, that one with the 1-inch square sensor.
Right.
There's a break point in the read noise at 100, and then if you look at the gain curve, the like the number of electrons per ADU, it's also at 100 is 1.
Why
Is
can't I
unity
find
gain.
On the right, Lou, on the right. There you go. That row on the right. Yep.
right there?
Yeah. Click on that and then scroll down. There you go.
Okay, everything correlates here,
Right.
right? But when you look at here though, gain over electrons, and look at the scale. It's
Yeah,
we're
but this
talking
is
point-
you're not on the correct camera. You're back to that other.
No, we're on this
That's
one.
the 2600.
Hold
We're
on,
on
let
this-
me get to. I'm sorry, I was on the 533.
But when we're looking here, why is the
See, the way that I've heard it explained, Lou, is that when you get to that 100 gain, it switches into a different mode, which is a much less lower noise mode.
yes,
Exactly.
yes, the two different algorithms that are, so what I don't get is this, I guess this scale must be the other mode.
It is when it drops down. That's where that kick is. That's when the other mode kicks in.
Right, but the thing is then unity gain, this should be, so it should be 1 right here at this,
I don't think that's what it means, Lou. I don't think unity gain means a gain of 1.
unity gain means you're moving
I
1
think there's an
ADU
equivalence,
per
but it's not-
electron,
it's not that
correct?
the value is 1, it's that there's a 1-for-1 ratio between the gain and or the photons and the signal, something like that.
All right, there's where the confusion is. Okay, I'm
It's-
sorry.
You look at the read noise chart. That's the chart you look at.
Yeah. I mean, I see your point, Lou. If you look at the 533 camera, look up that spec sheet real fast. You had it before.
533, okay?
Go to that. Here, the
Here.
breakpoint is
Perfect.
unity.
Everything here makes sense.
Right.
Okay, unity gain is 100, I'm sorry. We're moving 1 ADU per electron, per
Per
photon.
electron. Right. Exactly.
All right, per electron, I guess. Okay, the other one, no, it does not say that. It says,
No, it doesn't. You're right.
it says 0.8 or whatever the hell it was.
But ideally, regardless of the unity gain, you
Here, right
want to
here.
get to a point where that read noise
Exactly.
is as low as possible.
You want to be on this side. And because right here for this one, it doesn't make any sense to have any unity gain, any gain more than, you're not going to gain anything.
No, you lose full well depth.
Right, exactly.
Well, the only caveat is if you are using that camera for planetary, for example, you might be able to get faster frame rates,
Sure. Oh, yeah, yeah.
Right, that makes
Yeah,
sense. For
but
sure.
not for deep space. Yeah,
Right.
for deep space, just use unity gain.
Yeah, I wouldn't use this for planetary though, for sure. The $200 planetary camera is so much better.
Exactly.
Yeah. All right, guys. I'm sorry to keep you so long. Thank you for all your tips and information. What do you guys want to do for next month? Mark, do you want to do something? Or Gary, you want to present? Bill, do you want to present something? I mean,
I'm not far enough along to do anything, really. I've only
neither am
been-
I, but look what I pulled out of my ass.
Yeah, well, you know,
A
you
shiny
guys-
turd.
okay, I had the 45-day trial and didn't get to use the software all that much because of family stuff.
Oh, no.
But the thing is, you know, I bit the bullet, bought it a couple of weeks ago and jumped into it a lot deeper, and I learned a lot in the 2 weeks. So I feel good that you guys